Oh, yeah. So it's green. Yeah. So you should be able to hear it.
Okay. Do you see what's getting in? Oh, already.
You only need overlap.
Still,
Yeah.
Testing? Yeah.
Mute here.
Hello? Testing? Testing?
Testing. Can you hear me? I'm hearing my own echo. It does? Oh, I'm muted. No, there we go. It's my own laptop. Go right. Good.
Okay, I think we're ready to go ahead and get started. Session. It's my pleasure to introduce Derek Dreyer, who's a scientific director at the Max Planck Institute for Software Systems and an honorary professor of computer science at Saarland University in Saarland, Germany, as well as the recipient of the 17 ATM Robin Wilder Young Researcher Award. And his research explores the connection between type systems for high-level languages and separation logics for how low-level systems programming. And most recently, he and his collaborators have been working on Rust Belt, which is, of course, formal foundation for the Rust language, as well as Iris, which is a unifying framework for higher-order separation logic implemented in Block. And Iris is very well known, and it received the 2023 Award of Church Award for Outstanding Contribution to Logic and Computation, and a 2025 Most Influential Popple Paper Award. But Derek is here not to give sort of technical research talk, but instead tell us how to write papers and give talks that people can follow. So I think at this point, this is almost a classic talk in this space of like teaching people how to write. I've certainly pointed my own students to it, and he developed it together with Chris. So please articulate it.
All right. Thanks, everyone. So how's everyone doing? Excited? Excited for a week of ICFP and Splash? Yes? That didn't quite sound good enough. Let's try that again. Is everyone excited for a week of ICFP and Splash? Right. Good. Me too. So I'm also excited to give this talk. So this is a talk I've given, as Miliana said, a number of times at PLMWs. And it's on a topic that is kind of near and dear to my heart. It's something I think about, and I spend a lot of time talking about with my students when we're doing our research. And so I'm looking forward to telling you today some of the things I've learned. So to begin with, let me just say a little bit about myself. I am a researcher at the Max Planck Institute for Software Systems in Saarbrücken in Germany, and I'm very lucky. I've been there almost 18 years. And it's a very nice job in that I actually get to basically do research all the time. I don't have any other formal obligations in my job. And so you might think that being a full-time independent researcher means, this will work, yeah, that I get to do research full-time. That's the whole job, okay? But as you might guess, also from the subject of this talk, that's not all I do. In fact, just doing a piece of research is not really what this job is all about. If you just do research and you don't tell anyone about it, then you haven't really done science. Once you actually do some piece of research enough that you can publish it, then the next step is, of course, to write a paper. You submit that paper to some conference like ICFP or UPSLA, and if you are lucky enough to get in, it may take a couple tries, and then you get accepted to the conference, you go to the conference, and you give a talk. Once you give a talk, you may interact with other people at the conference, you get lots of ideas about new research, and the cycle continues. Okay, so I know some researchers who really are much more excited about the top state in this transition system versus the others. But for me, actually, I really like communication. For me, I don't actually know what I'm doing in my research often until we try to write the paper, and then it even becomes more clarified once we go to give the talk. And so I think developing these kind of communication skills are really helpful for building a successful career in research, but also in anything else you do in computer science. So this talk is roughly divided into two halves. The first half is going to be about advice about writing papers, and the second half is about advice for giving talks. And I'm going to start with writing papers. I should say this is an interactive talk, so I'm going to be asking you questions throughout the talk, but also if you have questions for me, just raise your hand, and I can always cut a little bit towards the end of the talk. So, first question: have any of you read any research papers lately? Okay, quite a few. I know some of you are just starting out, so it's I don't expect that so much. But and of those who've read some research papers, how many of you sort of threw up your hands in in disgust because you had no idea what was going on. All right, that was actually even a higher number than the ones who read the brief. Anyway, that's fine. Yeah, me too. So this is what it's still like for me, even though I've been doing this for, I don't know, many years. So you may think that it's just you're young, you're starting out, you don't lack the technical sophistication that you need to understand, a cutting edge research paper, and that's somewhat true. Certainly you do develop that technical sophistication as you go along, but there's another problem, which is often, many papers are actually poorly written. Or maybe that's even a little too strong. Maybe papers have limitations in the writing. There's various issues that make it difficult for people, even advanced experts in the field, to understand what's going on. And so the good news is, if you can write clear, accessible papers, many wonderful things are going to happen. Okay, so first of all, people will enjoy reading your papers. You'll feel good about that. People will learn something from your papers. You'll feel even better about that. They'll get accepted to top conferences at an astronomically higher rate. You'll feel great about that. You'll become famous. Your work will have a lot of impact. You'll make a lot of money. I mean, well, okay, maybe not the money. But a lot of good things will happen. All right, so why is this so hard? It boils down to something that Steven Pinker has called the curse of knowledge. And let me try to explain that to you. So basically, this thing in the middle is your research, right? This gadget. This is what you're trying to present to your audience. You want to tell the world about this, and you're very excited about it. You're this person on the left who's written this paper or actually done this research, and you're trying to explain this to your audience. Here's the reader on the right, and they're wondering. Oh, sorry. Actually, before I got that, this is first of all what your first attempt might be, right? To explain your research, you might say, well, I've been working hard on these pre-axial gaskets. So if we downcast those, then we can achieve 47% reduction in the whatever this nonsense. Okay, so you're very excited about all this stuff, right? And the reader is standing here scratching their head, saying, well, okay, but first of all, what does it do, and why do I care about that? And that's the first question they want to know before they get into any of these technical details. So why does this happen? Why do so many writers, say this very detailed technical stuff and not answer the basic questions of the reader? The main issue is this curse of knowledge. The curse of knowledge is the idea that the writer knows a lot more about what they're explaining than the reader does, obviously, and so they just have a hard time putting themselves in the shoes of the reader and understanding what it is they don't know, right? So what can you do about this? Well, the good news is there are principles you can follow that will help you overcome this problem and write clearer, more readable prose based on gaining an understanding of how readers process information. So when I tell you that I'm going to give you advice about principles of good writing that will help you write clearer prose, is there any kind of source that people might have recommended to you, some text that might have been suggested to you as when you're learning how to write? Curious. Strunk and White. Oh, I did not plant those people in the audience. Okay. Well, indeed. So, this trick works about 90% of the time. So this is the most commonly recommended book on writing, unfortunately. So this book is famous for a bunch of things like actually, let's see. Sorry, there we go. Yeah, for saying things like be clear and omit needless words. All right, very useful advice, right? Because if you knew how to be clear, you knew which words were needless, well, you wouldn't need this book. All right, so I've never understood why people like this book, but you can read it. There's nothing harmful in it, but it's not a very useful source of advice. And so instead, what I'm going to try to do is give you constructive advice. That is, the principles I'm going to show you are constructive in the sense that they're easy to check if your text satisfies these principles. And if not, then the principles suggest ways you can concretely improve your text, right? So they're not just sort of bland advice, but they're actually concretely helpful. So I want to say before I get into more details that this advice I'm giving you is not out of nowhere. It's actually inspired by various sources. One of the main ones is a book by Joseph Williams called Style Toward Clarity and Grace. You can find that online for free. It's free PDF online. There's some technical writing notes by Norman Ramsey, which I highly recommend. There's Simon Peyton-Jones has given several really good talks. You can find those online for about how to write a great research paper and give a great talk. And last but not least, I've developed all the material in this talk together with my wife, Rose Hoberman, who works at the Max Planck Institute. Her whole job is teaching students about writing and speaking skills and editing papers and giving feedback on talks and things like this. And she's developed whole semester-length courses on this material. So this is kind of a much condensed version of the material that she teaches all the time. Okay, so let's get started. So I'm going to divide this whole section of the talk into basically two parts. One about lower level writing and one about structuring of sort of higher level structuring of conference papers. So we'll start with the lower level stuff, sentences and paragraphs. So the first principle, I'm going to tell you about two major principles. The first one is called is related to flow. Okay, so the idea of flow is at a high level, it should be clear how each sentence and paragraph in your text relates to the adjacent ones, the ones before and after. Okay, and again, this comes back to the curse of knowledge, right? You can imagine that gap. You're trying to get across, pull the reader across this chasm. And so you need to sort of give them a chain that they can follow, right? They need to be able to follow each chain of your text from one part to the next. Okay, so if that chain breaks, they may fall into the pit, and okay, they don't know what you're doing. So let me give you a concrete example. I'm going to give you a piece of text. I'm going to read this to you, and I want you to think about: is there a point where the flow breaks? Okay. Security proofs of cryptographic protocols are crucial for the security of everyday electronic communication. However, these proofs tend to be complex and difficult to get right. The game playing technique, originally proposed by Jones et al., follows a code-based approach where the security properties are formulated in terms of probabilistic programs called games. This is a general design principle for cryptographic proofs to ease their management. Okay. Was there a place where the flow seemed to break? Yeah. Which one? The game playing technique. It sort of came out of nowhere. Right, exactly. Okay, so indeed, this kind of, what does that have to do with what came before? Okay. This is exactly where the chain breaks, right? You're introducing some new information out of nowhere, and it's not clear how it relates to the text that comes before. So what can you do about this? This is one of the easiest problems to fix, right? And it's also one of the most common, so it's a really good one to start with. And the principle for how to fix it is what we call old to new. So the idea is you want to begin your sentences with old information and end them with new information. Okay, so by beginning with old information, you create a link, or by old information, I mean referring to subjects that you've already talked about, right? That creates a link to the earlier text, so people understand where you're coming from. And then by ending the sentence with the new information, you naturally create a link to the text that's going to follow. And it also has the effect, at least in English, of putting that new information in a position of emphasis, because naturally when we read English, we sort of, there's a natural tendency to emphasize what happens at the end of the sentence. So let's see an example of this. So, okay, well, I mean, let's go back to our example of this paragraph. So you see, you can easily diagnose the problem here, right? We have new information here, which is the game playing technique, and it occurs at the beginning of the sentence. So it's a clear violation of old to new. Of course, this does mean you have to be able to analyze your text and determine, carefully what information is new at each point, right? But certainly when there's an important new concept, like in this case, this game playing technique, that should not occur at the beginning of the sentence. So how can we fix this? Well, here's one rewrite we could do. So, okay, I'm not going to read the beginning, okay, but however, these proofs tend to be complex and difficult to get right. To make it easier to manage such proofs, Jones et al. Have proposed a new design principle called the game playing technique. This technique follows a code-based approach where the security properties are formulated in terms of probabilistic programs called games. Okay. So again, you can now diagnose or do a diagram of this text to see where the old information and the new information is. And you see that at the beginning of every sentence, you have old information that's pointing back to some new information that was introduced earlier. Okay. Are there any questions about that before I move on? Obviously, it takes practice to put this, to actually deploy this principle in your own writing, but this is one of the most important. Okay. Good. So flow is great, really important, but it's also not enough. And the easiest way to illustrate that to you is with another concrete example. So what do you think about this text? Lions and tigers are some of the most dramatic and awe-inspiring species of cats. Most of these large cats, however, are currently facing extinction. A smaller cat that has been more evolutionarily successful is the house cat. Although house cats are currently the most popular pet in the world, they are in many ways antisocial. It would therefore be interesting to study whether house cats can be trained to be more sociable. Any thoughts? Yeah. Yes, exactly. It started in one place and it finished in a completely different place. But along the way, it took you along one step at a time. Okay. I mean, I can think of some movies that work very well this way. But for a paper, it's not so good. All right. So it's pulling you along, right? Follow the old to new principle perfectly well, but the beginning and the end of the paragraph are in like a different planet. Right. So the problem here is it has great flow, but it's incoherent. Okay, there's no clear point to this text. So the general principle, the high-level principle is coherence. It should be clear how each sentence in paragraph, or it should be clear how each sentence relates to the big picture of the paragraph that it's in. It should be clear how each paragraph relates to the big picture of the section that it's in. It should be clear how each section of your paper relates to the big picture of the paper, et cetera. Right. So you want to always know, like, what are we talking about here? So that's a very general idea. How do you concretely make this happen? The concrete principle is what we call one paragraph, one point. So the idea is that, and here it's focused on paragraphs. Okay, you can also lift this up to the level of higher level structure like sections, but we'll focus on paragraphs. So for one paragraph, each paragraph should have one main point, right? One thing you're trying to say. There could be, of course, a bunch of details, but there's one main point, and that is expressed in a single sentence we call the point sentence. And typically this point sentence, there's different places this can appear, but it shouldn't just be randomly. It should be in some sort of predictable place. And typically it's at or near the beginning of the paragraph. And I often think of this as being a kind of theorem proof model of paragraphs. Like you take the beginning of the paragraph, it could be one sentence, it could be two sentences, to establish the theorem of the paragraph. What are you trying to say in this paragraph? And then the rest of the paragraph is the proof. It's the details. It's sort of giving evidence for that point, right? So I should say, actually, sorry, I should say it can also. There's other places you could put this. In particular, another place that does happen is you sometimes see point sentences at the very end of the paragraph, and that sometimes has a good effect because it again has the sort of emphasis of like putting some emphasis on that point at the end of the paragraph. But that's a more advanced approach, and I don't recommend it in general for most paragraphs. So the problem here with this paragraph I read you before was there was no point sentence, obviously, because there was no point. there clearly can't be a point sentence in the paragraph. There's no point. So typically, if you can't find a point sentence in your paragraph that you've written, you need to do something more than just a local rewrite. So like the old to new principle, often you can fix those problems with local changes. With coherence problems, you often have to sort of think more about what am I trying to say. So in this case, okay, I'm going to think about what I'm trying to say here, and I'm going to say something different. So I'll change the paragraph as follows. There appears to be a negative correlation between the charisma of a species and its ability to survive. Lions and tigers, for instance, are among the most majestic creatures in the animal kingdom, yet they are currently facing extinction. In contrast, the house cat is evolutionarily quite successful, even though it is mostly known for stupid pet tricks. Okay, so this is an example of one paragraph, one point, a very simple classic example where the first sentence gives you the theorem, the point of the paragraph, and the rest is giving some evidence for that point. Okay, but as you see, we had to change the paragraph to actually have a point as such. Any questions about coherence? Okay, good. So those are the two most important principles. I apply these all the time. I think about them all the time when I'm writing papers. And if you can actually if you can actually adhere to these principles, I guarantee you your paper will be much easier to follow at a local level, right? In terms of understanding what the person is trying to say. Okay. So just to remind you, create flow with old to new, create coherence with one paragraph, one point. There are two other principles I'm just going to mention, which do come up a lot. I'm not going to go into detail about them, but just to mention them. One is something we call name your baby. So the idea is if there's things that you're talking about in your paper, they could be the system you're working or the whatever the lambda calculus variant that you've just developed or some concept in the language or whatever. Something that you want to refer to repeatedly, you want to give a name to that thing so that it's easy to refer to it, and you want to give a unique name, right? You don't want to give multiple different names to it. And so it's so this is a common problem I see in a lot of text. There's often someone will refer to the same thing in multiple different ways, or they'll never give a name to it, and they'll just sort of refer to it. Yeah, they won't refer to it clearly at all. So give unique names to the things that you want to refer to and use them consistently. The second principle is just in time. So this is also super important. Often, in order to explain something that you want to explain, you have to explain a bunch of other stuff first, right? And people often think, well, okay, that means I need to like section 2 of my paper should be background. I'm going to give a review of the whole field, and I'm going to talk about all these technical details about various things long before I actually need to talk about them, right? This is a mistake. Generally, if you talk about sort of technical stuff before it's really needed, people will just forget it by the time they need it. So the idea of just in time is give that more detailed information precisely when you need the reader to know it, not long before. Okay. There's actually a third bonus principle from Rose, which is really easy to remember, which is short subjects. This also I see coming up a lot, especially in student texts. In English, the subject of the sentence should not be that long, right? If it is, because when you're reading a sentence in English, you sort of the reader naturally wants to know what the verb is, like what's happening in the sentence. It also helps sort of get comprehend the structure of the sentence. So try to keep your subjects of your sentence, the first part, right, to at most around 8 words. So it's not of course there are exceptions, but that's a good guideline. Okay, so that's my advice about low-level writing. Again, these are very simple principles, but they're really really important in practice. So move on to how to structure a research paper. So I'm going to focus here. There's different kinds of research papers. I'm going to focus on conference papers. So the kind of papers you submit to conferences like ICFP, UPSLA, POPL, PLDI. Okay. In order to understand how to think about the structure of such a paper, it's important to understand like what you're trying to achieve, right? So the first thing you have to achieve, what's the first thing you have to achieve before your paper can be published? Yeah. Yes, yes. You'd have to do the research. Okay, well, let's say you've done the research, you're ready to write the paper. What is the first thing you need to achieve before, yeah. Yes, and after that? Yes, you submit it, right. Yes, okay. And after it gets submitted, it gets reviewed. Okay, so yeah, you have to get it past the review process, right? So this is an example. So this is I took this, I don't know, quite a few years ago from some program committee. So the way that our conferences work, you may or may not be familiar, is that there's a program committee for each conference, all right? Actually, nowadays it's much larger. It's like, I don't know, it's quite between 50 and 100 people or something like that. Your paper is going to be sent to some subset of these reviewers, not a large subset, maybe like 3 or 4 of them. Okay, it's important to understand what happens. What are sort of what are the facts on the ground about how these people are selected and what they may or may not know. So the first thing to know. Sorry. Oh yeah, there we go. The first thing to know is that the program committee is diverse, okay? Your reviewers may or may not be experts. You'll be happy if you get one expert, right? And I mean, the program chairs try to give you at least one expert review, okay? But like, even the definition of expert is not completely clear, and certainly it's the case that often you will get multiple reviews from non-experts, okay? Another thing is that the review period is very short. So typically it's around 2 months. And there may be, it varies for different conferences. Nowadays, we try to give reviewers somewhat fewer papers than they used to, but something in the vicinity of 10 to 20 papers per PC member. Okay, and so that means, and the PC members are just researchers, right? So they're doing research, they're teaching, they're whatever, they're going on vacation. I mean, they have all sorts of things they're doing in their life. They're doing this all for as voluntary work. to service to the community, right? So they often don't have much time to review papers, and they may only have like less than a day to review a paper, if that. Sometimes people have a few hours. So what does this mean? Okay, well, or what does this translate into sort of principles of what you have to think about? Well, the first principle is sort of overarching principle is what I call top down. Okay, so this means you need to explain your work at multiple levels of abstraction, starting at a very high level, which is accessible to the non-experts, and then getting progressively more detailed. Okay, and this is really it's useful for multiple reasons. It's useful, one, because again, there's going to be non-experts reading your paper. They don't want to. They're not going to be able to understand all the details of, immediately. And also, even for the experts, it helps them to get a high-level idea of what you're trying to do before they get into the details. The other overarching principle is what I call tell them what they want to know. All right. The reviewers don't have much time. Don't make them work for it. All right. make it as easy as possible for them to review your paper. So how do you do that? Well, they have basic questions they're looking to answer when they're reviewing a bunch of different papers and comparing them. Okay. So what do you think the reviewers want to know? Yeah. What's the contribution? Okay, yeah, what's new here? Yeah, yeah. What's the point? Why are we doing this? What's the benefit? Yeah, why is this important research to do? Yeah. I'm sorry, I didn't hear. Why should people? Well, yeah, that's sort of related to why is it? Yeah, what's the importance? Yeah. Yeah, that's usually. I mean, most people submit sort of things that are reasonably on topic, so that's usually not the biggest thing. But yes, it's sort of relevant to why is this an important problem? Yeah. Sure. Yeah, that's sort of going towards novelty. What is new about this paper that's different or better in some way than what's happening in the existing work? Or is that okay? All right. So those are a lot of the main things. So here's for me, the three most important things that I want to know when I'm reviewing a paper. Yeah, how is your work important? We got to that, right? What problem is it solving, and why does that matter to anyone? How is it novel? How is it compared to related work? How is it doing something that's better or different than what the state of the art is? And a third one, which no one mentioned, but I think is really important, especially for getting reviewers excited about your work. How is your work interesting, right? If you can explain what is a really interesting concept or an interesting insight in your work that enabled you to solve it, or that something unusual about what you're doing, that can help really get the reviewers excited about accepting your paper, right? I mean, they read a lot of papers, and yes, they will accept papers even if they don't find them exciting. But if they do find it exciting, then they'll be much more excited. And it's important because the way review process works, I didn't go into that much detail here, but like reviewers give scores, and they have, they can give a strong accept or weak accept. And typically for them to give a strong accept, they have to be a little more excited about it. And you need some people to give strong accepts typically in order for the paper to get accepted. One thing that sometimes people mention, which I don't usually put up there, is how is your work challenging? It's not that being challenging is bad. Obviously, it's good if you're working on challenging problems. But if you think in terms of trying to explain how your work is challenging, it often means that'll translate into trying to impress the reviewer with how hard you worked to solve the problem. And the reviewer doesn't care. Okay, they just want to know, is this an important problem? Is there a novel solution? Is it interesting? Okay. So those are the two overarching principles. I'm going to suggest one structure of a paper that I use a lot. Not all the time, but a lot of the time, or I use some variant of this a lot of the time, and I know that it works. So it has 5 sections. Okay, abstract, intro, key ideas, technical meat, and related work. And there's some information here. I've sort of given you some rough idea of how long this might be in a paper. I think I'm budgeting here for like a 20-page paper ish, or 25 pages. Yeah, any ideas of which one of these I'm not going to talk about today? Yeah. Technical meat, why? Well, 5 people read it. I mean, it's not nothing. But yeah, okay. So obviously 5 is maybe it's maybe an under approximation, but it might also be an over approximation. I'm sorry to say. So really, yeah, very few people will read the technical meat of your paper. You will be lucky if the reviewers completely read the technical meat of your paper. All right. So really, it's don't expect too much. Obviously, you want to write it well. All right, and it helps if you write that well as well. But it's a very special thing. It's a very, sorry, specialized thing, right? So it depends on the exact subject matter of your paper. I can't give you sort of very general advice about that. And in terms of number of readers, it's the least important. So I'm going to focus on the others, which I think I can give you some advice about. And we'll start with the abstract intro, which, as you can see, is, a lot of people do read them. So the recommendation I have for structuring an intro and an abstract is what I call the CGI model. Okay, and CGI here stands for context gap innovation. And I found this to be a really useful thing. I use this in almost all my papers, like regardless of how exactly the rest of the paper is structured. I try to structure the intro this way. So the idea is the context first is setting the stage, like motivating the general topic, like what are we talking about here? What is the sort of general problem space? Then we sort of narrow down to the gap. And the gap is explaining your specific problem that you're trying to address in your work and why existing work does not adequately solve it. Those are both important, right? You can't, it's not enough to just say, well, I'm working on this problem without saying something about the state of the art or why the state of the art is insufficient. You have to do both. And then that sets you up for the innovation, which is to say how you are filling that gap, right? State what you've done that is new and explain how it helps to fill the gap. I should say, you don't always have to completely fill the gap, right? I mean, sometimes you do, but sometimes you don't. Sometimes you set up a gap that's clearly defined and you chip away at it. You make a clear contribution to filling that gap. That's also okay. And so just to go back to those overarching principles, right? First of all, this is top down. You're starting from a very high level of the general problem you're working on, going to the specific problem, and then into the more details of what you're doing. And then in terms of what does the reviewer want to know, context and gap, that helps that goes to explain what is the importance of the work, like why should anyone care about it? And then the novelty, the innovation goes to explaining what, the innovation together with the gap explains what is the novelty of the paper. Okay, so I'll get an abstract for this talk. Actually, it's really just for the first half of this talk. So I'll just read it to you so you get an idea. Learning to write well is an essential part of becoming a successful researcher. Unfortunately, many researchers find it very hard to write well because they do not know how to view their text from the perspective of the reader. In this talk, we present a simple set of principles for good writing based on an understanding of how readers process information. Unlike such platitudes as be clear or omit needless words, our principles are constructive. One can easily check whether a piece of text satisfies them, and if it doesn't, the principles suggest concrete ways to improve it. Okay, so as you saw, right, there was the setting up the very general context. What is the problem we're trying to solve that researchers don't know how to write from the perspective of the reader, and then how do we address that? Okay. You also see it's not exactly half and half, but I often think about, and this doesn't always apply to intros exactly, but certainly for abstracts, I often think about a 2-paragraph abstract. The first paragraph is setting up the context and the gap, and the second paragraph is then like, in this paper, we do such and such that explain how that addresses the problem that was set up in the first paragraph. So it's kind of a little bit half and half. Any questions about that? Yeah. Yeah, actually, so here the advice here, I'm going to get to that in 1 second. Yes. Yeah, so this is sort of advice for both abstracts and intros. I both use the same thing for both, same structuring mechanism for both of them. For introductions, it's basically like an expanded version of the abstract, or probably more useful is to think about the abstract as a condensed version of the introduction. The only difference is, so some people, in particular Simon Payne-Jones, if you watch his talk on how to write papers, he recommends a different approach for introductions, which is basically, I mean, he doesn't frame it this way exactly, but essentially what he's proposing is eliminate the context. Just jump in right away with the problem, okay? And he often makes it as concrete as possible by saying, like, start with a concrete example, like consider this Haskell program, okay? And then it shows some code and then explains some problem that comes up with this. So if this works, it can be really effective. So if you know your audience really well, the problem is you have to know your audience really well. So if you're at ICFP and you're writing a paper in Haskell, yeah, okay, probably this could work. If you're writing a paper for a somewhat, some conferences are much broader. I mean, UPSL is actually much broader than ICFP, for example. So then it doesn't always work if your audience cannot be expected to be familiar with, sort of more minute details of Haskell. So if it works, it's effective, but you have to really check with your advisor, for example, that this is going to work. So mostly I don't do this. Okay. Any other questions? Yeah. Well, as I said, I usually do the context and gap in one paragraph and then the innovation in the second paragraph. It's personal preference. Yeah, I mean, none of this is hard and fast rules. This is just, these are structures that I know work. I use them all the time. I use that particular structure for the abstract pretty reliably just because it feels right. But it's my style, right? But different people have different styles. I think I think it works, but there's no fast rule about it. And I should say, sometimes I diverge from this. Like, for example, if you look at one of my papers that won a influential paper award, the abstract does not have this form. Yeah, I probably wouldn't have written it that way now, but I did then, and it, seemed to be okay. So there's different ways to write these things, but this is my recommendation. Yeah. Of academia. Okay, that's very broad. Certainly, I mean, there are differences. There are differences to a large extent. I mean, the biggest differences are in terms of space. So usually, my experience. I don't have firsthand knowledge of this. I have secondhand knowledge through Rose, who's my partner who teaches all these classes, and she gives feedback to students on topics across computer science, including many machine learning students. She basically doesn't change her major advice about like the kind of stuff that I'm presenting in this talk. So most of that she uses, when giving advice to students from across computer science. There are some things that are different, or there's some things that have there's a different norm in different communities. One of the biggest issues though is space. So but for the intro, I don't think it matters so much. I think the intro, these principles are basically, I would say this principle applies directly, and people use this principle in other areas as well. The next section that I'm about to talk about, that's one where sometimes if you don't have as much space, the key ideas section, if you don't have as much space, it's harder to do. My general feeling is if you don't have as much space, you can't write as good a paper. It's just as simple as that. You need space. All our conferences have sufficient space that you can write a good paper. I mean, by our, I mean like the SIGPlan conferences, ICFP, UPSLA, Popple, PLDI, they all have a reasonable amount of space. Machine learning conferences often have much less space, like half as much space or something, and then it becomes quite tricky to write as clear a paper. That said, yeah. So I can't give general advice across those conferences, but I think the CGI model definitely applies. Yeah. Indeed. Yeah. So wait like 2 slides and then we'll get to that. Yeah, I didn't plant you either, but yeah, it's coming. Yeah. Any other questions? Yeah. Yeah, that's a good question. Yes, he was asking what's the most efficient way to know the audience. That takes experience. So I'd say that's something where your advisor can often help. You learn this over time. You go to conferences, you see what kind of talks people give, what kind of assumptions they make. There's no simple advice for that. You just have to get some practical experience. But talk to your advisor. Often students, when I'm advising, they'll do a first draft of the talk, and I'll say, no, you can't assume that, or yeah, this is too basic. You don't have to present that. Things like this. So then, yeah. Okay. Oh yeah, one more question. Mm-hmm. I think there are certainly some communities in which certain structures, let me see how to say this as delicately as possible. There are some communities within computer science where the structure of the paper that seems to be the norm is, in my opinion, suboptimal in terms of communication. Let's leave it at that. So yes, there are communities where certain things are expected. If you happen to work in one, I mean, PL is not one of them. PL papers are generally, compared to many papers in other areas of computer science, are actually many PL papers are well structured, are well written, have enough space, etc. Like there's a lot of emphasis placed in the PL community on these kind of things. I'm not disparaging all the other communities, but PL is a particularly good in my experience in caring about those things. Some other communities, it's more like, show me the map or show me the graphs or whatever, like they sort of have expectations or explain, dump the related work up front, dump the background section up front, etc. There may be some expectations like this. And so if that's the case, you have to, then you talk to your advisor and you learn about what's expected and you work with that. But all I can do is give you the advice from the point of view of what is best for communication. Yeah, sure. Okay, I'm going to move on for time purposes. Next section is a section that many people, especially in other areas of computer science, but even in PL, don't necessarily have, which is this key ideas section. So what is this about? So the key ideas section is basically, it's sort of a transition between, like, the intro is explaining at a very high level what it is you're trying to do, or what problem you're trying to solve, what is your contribution, but it's not really in enough detail that the person can understand what you've actually done. So, but then again, the technical meat section is going to be too technically detailed, right? And so you need something to bridge that gap, right? You need something to bring the reader along. And this is what the key ideas section is about. You can think about it as like, you're trying to explain someone at the whiteboard what your paper is about. How would you do that, right? You wouldn't show them the full technical details of your system. You would put up a couple concrete examples. You draw some pictures. You'd work through some simple examples of the problem you're trying to solve and how you solve it, okay? That's exactly what this section is about, right? You're using concrete illustrative examples and high-level intuition to explain your contribution. You don't have to show the general solution. That's what the later sections are for. You're instead trying to you're trying to give the idea of what you're trying to achieve, and also what is interesting about it. So if we go back to this question about, where do we get to the interesting part? Okay, this is the key ideas section. This is one of the main points of this, is to make it clear to the reader what is interesting about this paper. So first of all, it forces you to have a sort of takeaway of the paper, like something the reader can take away, even if they didn't care about all the details of what you're doing. Like, what's the conceptually interesting bit? So that's one reason for this section. Another is that many readers, as I've already said, will not be reading the technical details, but they may still be interested in getting some general takeaway of, like, what's the point of this, or like what's really going on at some, at the essence. So they only care about that takeaway. And then third, even for those who do want to understand the technical details, like the experts, I can tell you, as when I'm an expert reviewer, I want this section, right? I want to know at a high level, what is the concept of the solution, right? I don't want to just jump into the technical details. So these key ideas are still useful as a kind of scaffolding, even for experts. Okay, sorry. So yeah, that's key ideas. Any questions about that? Yeah. Oh, yeah, that's a good question. Right. People always ask, what do you call this section? You call it whatever you want. I often call it key ideas. I call it main ideas. Sometimes I call it overview, although that's a loaded term. So overview can mean many different things. It doesn't always convey. It can sometimes mean like, just a high-level system description or something. So that's not always the same thing. This is really about the ideas. I should say, in some papers, it doesn't quite work. Sometimes your paper doesn't have, well, it may have ideas, but they're so technical that you really need to, you need to structure things in a little bit different way. So sometimes I have a section called tour of the system or tour of something, but it's similar to this section in that I work with concrete examples. Like, maybe we developed a new verification system and we're going to show a bunch of examples to illustrate different features of the system, right? We're not giving all the formal rules of the system, but we're going to use concrete examples as we would explain it to someone, maybe like in a talk, right? So it can have different kinds of, there's variations on this. It's not like it's always exactly this form, but it's this concept of telling the reader what's interesting. Yeah. Oh yeah, go ahead. That's okay, right? So yeah, okay. So the question is about, like, if you're explaining the work multiple times, isn't this too much or something like this, right? So that's sort of what you're saying. It takes too much effort. Yeah, generally it's okay. It's okay to actually get through. It's actually good to explain your work multiple times at different levels of abstraction. That's fine. And sometimes you'll first present, maybe your work is, because I've had papers where the technical The actual solution was really complicated because often it's complicated not because that's a bad thing, but because it is combining a bunch of different things together, right? And when you combine them all together, it looks really complicated. But each individual thing is not so hard to explain. So maybe you explain some of those individual things in isolation first in this key ideas section, and then later on you show how you can put them together. So that's perfectly okay. Yeah, one more question. Yeah. I mean, yes, sure. I mean, that's sort of a detail. Both could work. Both could work. Okay, and move on. So lastly, related work. Okay, as you see, there's a lot of people who read this, right? So this one is one of the more read sections of the paper, right? And why do you think that is, actually? Yeah. They want yes, right. Okay. Yes. And you've seen Family Feud, there's like a different survey of possible answers there. Ding, ding, ding. Number one is people want to see if their paper is cited. Yes, that's right. Of course, I mean, I confess, I'm not, I have done that. So it's only human, all right? But so that's one reason, of course. But also for reviewers, they want to understand, they often, if they know something about the topic, or even if they don't, they may skip to the related work section and check it. I mean, I'll certainly read it. That's one of the sections the reviewer will definitely read because they want to understand how your work is comparing to the state of the art. Right? That's like a key thing they need to understand in order to review the paper. So they may even read it. Wherever it is in the paper, they may jump to that section and read it at some point. Okay, but what is the advice I want to give to you about this? The first is, I would put the section, and there's people who differ about this, but I think you should put the section at the end of the paper. Okay, why do I say this? It's because you can only really properly compare in detail to related work once you've explained your own work. Okay, and you haven't explained your own work until the end of the paper. Okay, so to be clear, this doesn't mean that you don't mention any related work until the related work section at the end of the paper. Of course you do, because in the intro of the paper, you're going to explain the gap. When you explain the gap, you're going to say something about the state of the art and why it is insufficient. So you're of course going to say something about related work in that introduction, but that's going to be a much higher level of abstraction. That's going to be sort of just stating things about, or maybe going into a little bit of detail, but only a little bit about what is not solved by related work. The difference is at the end of the paper, now you've really explained your work in detail. Now you can give a more detailed substantive comparison about technical points. That like maybe things that related work doesn't solve that you do, or even the vice versa. There might be some limitations of your work that are solved in some other pieces of related work, even if those pieces of related work don't like subsume what you've done. So this really should go at the end of the paper. The second thing is just to give real comparisons. So the thing that's most annoying to reviewers is when you just give a laundry list. Like the review, I mean, also even for me, like if someone cites my paper and just says like, they did some stuff. This is not, that really annoys me. So I'd rather, I mean, I'm happy they cited me, but I would rather that they actually said something useful about the comparison with my work so that I can understand what the connection is with what they're doing. Okay. Okay, so that's related work. Any questions about that? Yeah. Yeah, so right. So often people have what's called a future work or conclusion section at the end of the paper, typically at the end of after the related work, basically. And that's fine. I sometimes do that. It depends mostly if I have something very interesting and tangible to say. A lot of the time when I write the paper, like I don't know where things are going. Sometimes there's very specific limitations of the work, which I have made explicit in the paper, and then you have an opportunity to say something about how we might resolve those limitations. But this is I would call an optional section. Some reviewers, by the way, sort of insist on this. Sometimes you'll get a comment saying like, I was surprised that the paper didn't have a conclusion. Okay, well, it's usually not a deal breaker. I haven't seen papers that were rejected because the author didn't put a conclusion. If that happens, I say, oh yes, we'll be happy to put a conclusion. Okay, but I don't think it's necessary. Yeah.
There's sort of the tension of like what is ambient knowledge, right? We already talked about. And if you're taking a particular theory or particular application, you're taking it in one direction, and you want to say, oh, and other people took this in these other directions. Are you saying like you don't necessarily need to cite that because like putting a citation if it's not directly applicable?
Oh, I see. Well, sometimes you do include some related work. So often related work, I didn't talk about how you structure it, but often your related work will be structured into, different themes, like different axes of comparison. And one might be like, we're working on this aspect of the problem and these other people are sort of taking it in a different approach. And they're not really comparable. They're just sort of doing something different. I generally try not to spend too much time on that just because it's further away, right? But yeah, you could certainly mention that. That's fine. Okay, so to summarize, flow via old to new, coherence with one paragraph, one point. Name your baby, just in time short subjects are useful sort of general principles. For the structuring of a paper, use the CGI model for the abstract and the intro. Layer your presentation, sort of build, get the reader closer to the technical details with this key ideas section, and the detailed related work section. Yeah. Mm-hmm. It depends. I mean, typically one generally hopes that you've explained enough background in your paper already in explaining your technical work that you don't have to introduce a whole bunch of new technical material just to explain the related work. So typically you don't do that. There's just not enough space usually. So you can you don't have to. You certainly it is not a goal to make it completely clear what exactly the related work is doing. That's often hard to do, right? Oh, I see. You mean for your paper, oh yeah. Well, then you may need to give background again. So this is where something like the just-in-time principle comes in, right? So all I can advise there is try not to just have a big. Sometimes people have a big background dump in section 2 or whatever. It's really like a wall of material that people have to get through before they can even get to the like in Simon Payne Jones's talk. I think he uses the analogy of like a mouse looking for cheese. I think that's what it was. So the reader is kind of this mouse looking for the cheese, and if you put this background section, between the reader and the cheese, they may not get there. Okay, they want that cheese. So yeah, you certainly have to give some background, but try to integrate it into the explanation of what you're doing. Yeah, it could go in explaining the key ideas. You explain just as much background as you need in order to explain what your ideas are. But yeah, I mean, sometimes it's very difficult. I'm going to move on. Sorry, I know there's more questions. I have to, for time purposes, I need to get to the next part of the talk. But I'm happy to take more questions about all this stuff afterwards. So that was writing papers. And move on to giving talks. Okay, so you've written your paper, you've got accepted to ICFP or UPSLA. Now it's time to prepare a talk. This is very exciting. Okay, so there's many great things about giving a talk. One is, you get a lot more people paying attention to you, right? So when you write a paper, you sort of throw it over the wall and hope someone reads it. When you give a talk, you're there with the audience, right? It's a lot of fun, actually. I mean, it's kind of scary, but it's a lot of fun to have all the attention of all those people at once. You get a lot of advertising for your ideas, and a lot of people paying attention to you at the same time. So that's really good, way of disseminating your ideas. So the problem is it doesn't always look like this. Okay, although I was once in a popple in Venice that looked a bit like this. But no, so it doesn't always look like this, not only because of the shape of the theater, but because the audience is often looking more like this, right? I'm sure you're familiar with that, being one of those audience members. And if you happen to get at the wrong moment of the day for jet lag, then it may look more like this, right? So these are dangers of giving a talk and things that make it actually quite challenging. For me, actually, I find giving talks to be more challenging than writing papers. A lot of people find the other way around, but yeah. So I think it's really hard. So what can you do about it? So one piece of advice, let me just start out with a piece of advice which I'm not giving, is a piece of advice that Simon Payne-Jones gives in his talk on giving talks, and John Hughes also gives in his talk. These are, by the way, very good talks. I think you can find the recordings online. But okay, one piece of the advice they give is to entertain your audience. Like you gotta, your mission is to wake them up. Your most potent weapon is your enthusiasm. Put on a show, right? So the problem I have with this advice, I mean, it sounds nice. Okay, it's great. The problem I have is basically I find it not very constructive. Okay, because I don't know how to teach people to be entertaining, right? I've never learned how to do this. And some people, many people in our field, all right, are just not that entertaining, right? I'm sorry. It's a fact of life. Many people are somewhat introverted, and that's fine. So you don't have to put on a show, right? Obviously, if you're able to put on a show, that could be a good thing. It could also be a bad thing. I've seen many talks, I have to say, from people who are a bit more extroverted that make me want to throw up, okay? So I like really where they're just like way over the top, fancy, super fancy animations. They're like have too much personality. You're just like, take a chill pill. So I think this is not the most useful advice. Obviously, if you can give an entertaining talk that's well moderated, it can be extremely effective. But I think I want to give you some advice that's a little more generally applicable and constructive. So. The way I'm going to do that is again thinking about like what is the difference between giving a conference talk and writing a paper. Right? What are the challenges that are unique? There are many challenges that are the same, basic issues of communication, but there are some challenges that are unique to giving a conference talk. Right? As I said, the plus side of giving a conference talk is very clear. You get great advertising for you and your work. But what are the downsides? What are the pitfalls to worry about? Time constraints. Yes, you may not have enough time. Indeed. Yeah. That's true. Right. But yeah. So yeah, that's a punishment you get if you give a bad talk. That's true. Yeah. Yeah, they can't rewind. Yeah, that's exactly right. When you're writing a paper, when you're reading a paper, and in fact, I think we all have this experience. You're reading the paper, you didn't understand that section. You go back, you read it again, or you wait a week, and then you switch, you move around, you hop around to different parts of the paper. You do whatever you want. Can't do that in a talk. Yeah. The question part, yeah, actually, so I actually am not. I'm not giving any specific advice in this talk about question answering, mainly because it can be quite topic specific, but yes, that's of course true. Yeah. Anything else? Okay, so several things were mentioned already. The four key things which I'm going to talk about are, first of all, yeah, you can't say much. You don't have much time, right? It's a short talk. Two, one thing people didn't really mention, the audience may or may not care, right? So typically this is a little different for papers, because if someone takes the trouble of actually downloading your paper and starting to read it, that required some sort of proactive step. So maybe they at least have some initial interest in what you're doing. That's not the case in a conference talk, right? There's going to be many people in the audience who are just hanging out there. They're sitting in that session. Maybe they were interested in some other talk, or maybe they don't know what they're interested in. So you have to get them to care. You have to do more work to get them to care. Third, yeah, as we discussed, right, it's very easy to get lost in a way that it's harder to get lost in the paper. You just might, miss something, and then you're out of it. And then lastly, slides are a visual medium, right? It's a visual medium in a way that a paper clearly is not. So your slide design matters a lot. And for those of us who are not as like naturals at design, then this could be tricky. Okay, so I'm going to talk about all these 4 points and give you some advice about them. We'll start with the first one. So you can't say much. So you're starting to give your talk. What is the sorry, actually I have to push this setup. I can't see what the next slide. Oh, right, now I know what it is. Okay, good. Yeah. We already talked about a paper structure that works. So when you're converting this kind of structure to giving a talk, which elements of this paper structure do you think will remain? Key ideas, anything else? Did you say so? Intro, yes, okay, good. Yeah, intro and key ideas, exactly. So yeah, you still need an intro. Yeah, you can't you can't get by without the intro. That's sort of framing the whole thing. But yeah, intro and key ideas, that's the talk. Okay. If time permitting, you may have a little time to talk about related work at the end. Okay, but mostly almost all my talks are conference talks are of this form. Okay. It's just that you don't have much time, right? And roughly to give you an idea, okay, this is again, this timing is if you have a 20-minute talk. I don't actually know what the talk length is at ICFP this year. Maybe it's shorter. Then you adjust accordingly. Okay, but roughly something for a 20-minute talk, be like 8 minutes for the intro and most of the rest of the time for the key ideas. I often leave 1 minute at the end for a kind of summary of, it's kind of an ad for the paper, like what else is in the paper? Because often, again, not only are you giving intro and key ideas, but you may not have time to explain all the key ideas, right? You may only be able to explain something. So often there's going to be some piece of the work that is left for the, there's actually often a lot of the contributions that you really haven't explained. So you just put a little ad at the end, like one slide to say, and if you found this interesting, here's a bunch of other stuff that's in the paper. Okay, so that's it. Right? It's pretty simple. In terms of the structuring of these things, well, we're going to get into that now. Okay, so that's just in terms of like how much you can actually say. So in terms of getting the audience to care, okay, you're starting your talk. What is the first thing you think the audience wants to know? What? Why? Oh, who are you? Who are you? Oh, okay. Yeah, that's usually not super. Sometimes you're introduced. I mean, yes, of course, you could say something about who you are. It's good to state your name. Yeah, okay, that's true. Or maybe name your co-authors, etc. Yes. Okay. Beyond that, what's the next thing? Yeah. Why should I? Yeah, exactly. So, well, okay. In particular, like, what is the problem you're trying to solve, right? Why do I? In order to understand why you care, you have to understand what is the problem that's being addressed here. So the difficulty, the reason this is harder than in a paper is, again, timing. You can easily lose the audience if you just like read the intro to your paper. Okay, the audience would fall asleep. Okay, so that's too slow. You need to be much faster. And typically the way that I recommend doing this is to stage this motivation. Okay, so first get to a problem. Okay, in the first 2 minutes, get to a clear statement of some problem. Okay? It may be a very general problem. It's not the specific problem you're working on, but it's something that is like, this is an important general problem to be working on. You don't have long, just at most 2 minutes before you get to this problem. Okay, and at least that sort of gives people a reason why they should maybe keep listening. All right, because otherwise, if they don't hear that very quickly, they may just start reading their phone. Okay, then you get to the problem. Okay. And so that buys you did the first 2 minutes, you have the general problem that buys you maybe another 4 minutes or so to actually get to the problem you are trying to address. And the key thing here is you want to you want to explicitly state this problem. I can't tell you how many talks I've seen that do some motivation and then like never state the problem. They just sort of start talking about the contributions, right? And this is confusing because then like you're still not clear what is the actual problem that the person is solving. So state that problem explicitly, and as in a paper, limit the discussion of related work to only what you need in order to explain your problem. You don't have to mention all the things that are out there. You have a story in mind that's explaining what is the problem you're solving. You mention the most closely related work that would be attacking that problem and why it's not sufficient. I gotta go about the next step. So the next step is, right, now that you've explained what your problem is, now the audience member, is ready to actually hear what you did. Okay, so tell them what you did, right? And again, this is something I've seen some people do is they motivate the problem and they explain what the problem is, and then they just start talking about stuff. Getting into the technical details of the work, right? Again, this is very confusing to the audience. They're primed at this point. They understand what problem you're trying to solve. They want to know now. They want you to tell them what is it you actually did. So have a slide called contributions, right, or something like that, right, that very clearly states this is what we did. And this is one of those slides. Mostly, bulleted lists are a little frowned upon these days, and for good reason. Although I use them, as you see. But I don't use them on every slide, though. We'll get back to that point later. So, but you know, it's fine on a contribution slide to have a bulleted list of contributions. That is perfectly expected because this is where they want to know what is it you were claiming to have done. Okay. And you know, this is you know, proudly explain that. Tell them. Then what I typically do, or I try to do, is to follow that slide directly with a crisp statement of the key ideas. So like go to like the very high level insight of how you achieve those contributions, like ideally in 1 or 2 slides, which you can think of as kind of a theorem that you're going to prove with the rest of the talk, right? It's the rest of the talk is all about key ideas, right? This is the contribution slide is the end of the intro, transition right into the key ideas, and now you can explain the key ideas at a high level, and then you spend the rest of the talk basically justifying or going into more detail with concrete examples, et cetera, to explain those key ideas. Okay. Any questions about that? Hmm? Mm-hmm. Right. Oh, sorry. I gave time. I gave timing. Yeah. Yes. Yes. That was like a 20-minute talk. So if it's so you have to adjust accordingly for different like talks. But yeah, I mean, sometimes the intro is really important, right? You have to make sure people understand what problem you're solving, what you did. That you don't want to skimp on the intro like that. And often, if it's a shorter talk, like a 15-minute talk, yeah, I might spend a full half the talk explaining just the intro, and then the rest is key ideas. Yeah. Like really don't, you know, you want to make sure people understand what you did. Yeah. Yeah. So a problem is, this is more like, you can think of this as more like context. It's like, this is the general space of things we're working on. It may be a little more detailed than the context in the paper. So often the context at the very beginning of your paper is very general. Like, I don't know, we work on verifying concurrent programs or something. I don't know, it can be quite general. In the talk, you want this to be a little more specific than that, but still is not the very specific gap, right? You're not explaining that specific thing that only your paper is making a novel contribution to, right? You're going for somewhat higher level generality. You don't necessarily need this if you can explain your problem really quick. Like maybe the problem you're working on is so clear that you can explain in 2 minutes. It just doesn't happen very often. So the point is to get to some kind of problem statement that encompasses your problem, but is not the very specific one. Again, this is I recommend like look at talk with this advice in mind when you watch talks at the conference. See what they're doing. See if they're stating some clear problems up front that are more general. Right? Maybe they are, maybe they aren't. Maybe sometimes you can get away without doing it, but that's my advice. Okay, I'm going to move on again for time purposes. So next point, even those who care will easily get lost. Okay, so this is much like in a paper. Remember we had flow and coherence? Well, we have flow and coherence in a talk as well. Right? These are also relevant concepts in giving a talk. In a paper, we created flow with old to new and coherence with 1 paragraph, 1 point. Let's do this one step at a time. So for flow, let's see how do these concepts apply in a talk. With flow, it's mostly the same as in writing, actually. So the way I like to think of it is within a slide, the script should follow the old to new principle. So like if you don't have to write a script for your talk. Okay, I'm not saying you should do that necessarily, but sometimes I do. All right, it's perfectly normal to write scripts and to practice with scripts. Nope, there's no shame in that. And if you think about the script you're saying, it should follow the old to new principle, right? Just like that just makes the text easier to understand. The other thing, though, is in a talk, it's not just within slides, but between slides. And there's a visual sort of like discontinuity because suddenly the screen is changing completely. And here, my advice is to keep the flow between slides. Don't just flip to the next slide and say, so let's start talking about something else. Plan to say something during the transition, right? Like you can even have something that you're saying while you're moving to the next slide. Okay. So, okay. So we just talked about. Let's go back here. Okay. Yeah. So right, we just talked about. So that concludes our discussion of flow, and now we're going to talk about coherence. Right. So that's a better transition between the slides. So what do we do about coherence? Clearly, we don't have paragraphs in a talk. So what do we have? slides. Okay. So the principle is very simple. One slide, 1 point. Okay. That's the sort of basic unit of the talk. Let me just show you an example of, well, yeah, I'll just show you an example. All right. So look at this slide and see what you think about it. Take like, 10 seconds or so. Yeah. You don't say. Okay. So why? Well, okay. Just like 4 slides in one. Yeah, okay, exactly. Right. So yeah, there's too much information here. Okay, there's actually multiple problems with this slide. Obviously, the font situation is leaves something to be desired. But that's a secondary point. The main problem is like, there's too much information. It's like there's multiple different slides. This slide needs to be broken up into several points. I'm not even going to try to explain the slide. Okay, you can see there's like there is a chain of thought. Actually, there's some flow here, but it's just too much information. So it's again one of these things where the slide is incoherent. So yeah, with a situation like this, you want to break the slide up into multiple slides. That means explaining it a little more slowly, right? You can't just cram information into a shorter time. It doesn't work. You have to explain it at a natural speed. And if you do that, that also leaves you more room to have more interesting visual elements on the slide, and maybe give some concrete example to illustrate the point you're making, or have a graph or whatever. I don't know. So it'll just improve the slide overall, in addition to making it more coherent. Another element of coherence. So that's coherence sort of at the level of individual slides, but there's also coherence at the level of sections of your talk. Like, I said you have 11 minutes for your key ideas, right? That's a long time, okay? You need some structure there. And so the way I typically think about this is in terms of talklets. So these are like little sections of your talk, or maybe little, they're stretches of the talk that have more digestible units of story. You can think of it on the order of like 2 to 4 minutes per talklet. These talklets again should have some structure. Like, what are we like? Let's talk about this subproblem, and then you discuss that, and then at the end of it, you need to actually summarize what was it we learned from this thing. The key thing here is also that you need transitions between these talklets, right? So often, when you structure things into talklets, when you're done with one talklet, you don't just immediately move on to the next talklet, then the audience may be confused. You sort of try to pop up to the big picture and remind people of, so where were we again, right? So we solved this subproblem, number 1, but now we have to go back, we have to look at this subproblem, number 2. And this could be one place where some kind of outline slide could be useful, right? You may have some outline slide that you use in a longer section of the talk to structure things. Like, for example, the one that I've been using here, right? This is an example of talklets right here. I've been giving like 4 different talklets for these different points. And I use this one slide to sort of pop up back to the big picture again and say, okay, remember, we're talking about different aspects of why a talk is hard to give. So that's a generally useful concept. Okay. Any questions? I know that's pretty high level, but it's something I think about when I'm structuring a long talk. Okay, good. Oh yeah. Reconnect. Yeah. Well, one thing is, again, to have slides like this, something where you're clearly popping back up, right? So maybe they got lost in the details of some point that you're making. But if you have a clear point where you say, okay, so we just talked about this, and you summarize what it was, and now remember, the big picture is we're trying to understand all the challenges of giving a talk. And so now let's move on to the 4th challenge, right? And then so maybe that's something where they'll think, okay, well, I didn't understand the 3rd challenge, but maybe I can understand the 4th challenge, for example. It is so. Another thing which I hesitate to mention is that this is one place where jokes can be useful. I hesitate to mention this because, yeah, you want to be careful with jokes. First of all, sometimes they work, sometimes they don't. Often they're cringe. All right, like you'd have to really test them out for some audiences to see if they work, right? So, but that certainly. Or maybe not, instead of a joke, it could be a very interesting or funny visual or something that like catches the attention, maybe the reason a joke, why do I mention a joke? It's because ideally it gets laughter. And laughter then wakes people up. They're like, oh, I wasn't paying attention to the talk, but now, okay, now it seems like it's funny. So okay, I should pay attention. So it's, again, it just sort of resets things. But of course, if it fails, then it doesn't. Okay. All right. Okay. So for the last part, I'm going to talk about slides, right? So there's many things to say about slides. I'm going to focus on two main things that I find useful. And again, I'm not someone who's natural at design, right? And you don't have to be. It often feels daunting to me to make slides because I can't draw. Okay, and so I have to do the best I can with trying to structure things well. So so what is my advice? So the first piece of advice I'm going to illustrate with a slide, and this is which I'm going to present to you. So this is a slide that I've used. Well, okay, it's based on a slide that I use in a talk I give about my work on Rust, the Rust programming language, where I'm introducing some aspects of the Rust of what Rust is. And I'm going to start by giving you a I believe the word is enshittified version of the slide. Okay. So and then I want you to say what you think has been done to it. Okay. So I have to remember what I have to say here. Right. So the core idea of Rust is that the root of all evil in systems programming, so to speak, is the unrestricted combination of mutation and aliasing. For example, if you have some shared object in memory and you have multiple references or aliases to that object, and one of those aliases is used to mutate and then potentially reallocate the object, that can lead to all manner of anomalies like dangling pointers, use after free errors, data races, iterator invalidation. These are all kind of well-known problems that plague C and C++ programs. And so the idea of the Rust type system, or the idea of Rust, is to prevent all of these kind of errors at compile time using a sophisticated type system known as an ownership type system, which essentially ensures that objects can either be mutable or they can be aliased, but not both at the same time. Okay. What did you think about the slide?
What's the core idea of Rust?
Yeah, I mean, I did end up talking about it preventing these errors. So that is clearly written on the slide, I think. But yeah. Okay. Yeah. It took a very long time to get to my point. Yes, that's right.
The follow-up was
Yeah.
started off by, like, I think the core idea of Rust, according to this slide, is the ownership system. But you started off by saying the core idea of Rust is, and that there was like a lot of other stuff before we got
Yes.
the ownership type system.
There was indeed. So that's, in some sense, you could say this is partly the issue is one slide, 1 point, but it's a little more complicated than that. Yeah. Oh. Yeah. I have a figure I never refer to it. Yeah. Okay. So I did talk about things that are happening in the figure, but yes, I never sort of like, it wasn't clear. Yeah. But oh. You see it. There's many problems with this slide. It's very good. Yes. Yeah. Go ahead. Everything is shown at once. Yeah. Okay. Good. All right. You're getting closer to what so I'm going to thank you for all the good. Those are all issues. Those are all good issues. That's closest to what I'm getting at here. It's not clear where you should be looking. Right. I talked for a while. There's a bunch of stuff on this slide. It's like, where are you supposed to look? Right. So I actually originally didn't have this point in my talk, and I saw I watched Ranjit Jala give a very good talk at one of these PLMWs on how to design talks, and he made this point. He called it make the focus. Make the focus of the audience's attention obvious. Okay. I rephrased this to slightly to say, make it clear where to look. All right. So like, if you want the audience to not be confused about which part of the slide they should be looking at. And so, yeah, the way I'm going to illustrate this is by going back to the slide and showing you now how I actually do it in my talk. Again, it may not be perfect, but hopefully you'll see that it's a little better. Okay, so the core idea of Rust is that the root of all evil, so to speak, in systems programming is the unrestricted combination of mutation and aliasing. For example, if you have some shared object in memory and you have multiple references or aliases to this object, and one of those aliases is used to mutate and potentially deallocate and reallocate the object, then this could leave you with all manner of anomalous problems like dangling pointers, use after free errors, data races, iterator invalidation, all well-known problems that plague C and C++ programs. And so the idea of the Rust type system is to prevent all these errors using a sophisticated, what's known as an ownership type system, which essentially enforces that an object is either mutable or aliased, but not both at the same time. Okay. Okay. So there's probably ways this slide could be improved further, by the way. Like it's not, I'm not saying this is perfect, but at least you see, I sort of stepped, I used, what did I do? I used animations. They weren't fancy animations. I did do one smooth animation here to, when I said potentially mutated or whatever, potentially deallocate and reallocate the object. Because that's kind of a slightly hard thing to visualize. So I think this helps to sort of show the deallocation. But otherwise, mostly it was just about staging the presentation, right? And in some sense, this wasn't one slide. It says core idea of Rust at the top, but there were several different visuals, so you could view it as kind of like a continuous slide that changes over time. Use animations to stage the presentation, and always make it clear using. They also help to make it clear where the audience should be looking. Okay, that was the one main point. Another one is about, well, it's best to just illustrate with this example. So I'm going to show you two sets of slides. This is like the slide sorter mode in PowerPoint or Keynote or whatever. Look at this set of slides, and then I'm going to show you a different set of slides. Look at it for like a few seconds. Okay, that was number one. This is like going to the optometrist's office. Slide one, slide two. Slide two, slide one. You have astigmatism or not? Okay. So go ahead. So what do you think about these two sets of slides? Too much text in the first one? Right. Yes. There was a lot of text in the first one. Yeah. Anything else? Why was it boring? All right. Right. Okay. I did not plant these people. All right. So those are exactly the two issues. So yes, first one, don't put lots of text in the slide. So this is sort of PowerPoint-itis, right? PowerPoint especially makes it really easy to have like lots of text in your slides. I should say there are some talks, maybe in a lecture in a course where you're trying to just dump a bunch of information or something like that. Maybe this can work sometimes, but I'm talking here about like a conference talk. You don't want to have huge amounts of text in the slide. People will just not read it. And they'll have a hard time focusing on what they should read. The second one is, vary the look of the slides. The slides here were boring because not only was there a lot of text, but they looked the same. You start to feel like, oh, this slide looks just like the last one, and you kind of get lulled to sleep, right? Whereas here, I mean, you don't even know what I'm showing here, but you can see there's some pictures, there's some different visuals, they're different structurally. Like, and throughout this talk, for example, I had some slides with a lot of text, but I varied them. I mixed them up. I tried to not have too many of those in a row, or else you start to feel like, okay, fall asleep. You want to keep it moving, right? Keep it changing. Okay, so those are my main comments about giving talks. So to summarize, talk is not the same as a paper. It's harder for various reasons. Intro and key ideas are all you really have time for. First, get to a general problem, then get to the specific problem. State your contributions. Make sure you actually have a slide that states them clearly, and then follow that up with the key ideas. Flow via old to new as before, but with some transitions between slides. Coherence with one slide, one point. Make it clear where the audience should be looking, and try to avoid lots of text and vary the look of your slides. And if Ranjit Jala were here, he would say, is that what you call avoiding lots of text? Okay, but nobody's perfect. Thank you. We actually have a few minutes for questions if there's additional questions. Yes, go ahead. Mhm, mhm. Right. Okay, so good question. So the first question was, sorry, what was the first question? Oh, interaction with the audience, right? Okay, good. Interact with the audience in the last slide. So, okay, regarding interaction with the audience, in a conference talk, not typically so clearly in the talk today, I had a lot of interaction with the audience, but this is a special kind of talk. There's also mentoring talk, very different. For a research talk that you give at a conference, you typically don't have interaction with the audience. I mean, obviously you want them engaged, so you're happy if they laugh occasionally or they, I often look at the audience. I use it as a kind of to make myself feel better mostly. I'll look at people in the audience. Some people will be engaged, right? Hopefully. And typically, no, there's typically quite a few people engaged, and there's some people who are like really engaged, like they're like looking up, they're smiling, they're very reactive. That happened today. There were certain people in the audience I looked at. I would look at them and say, oh, they're really into it. Okay, that's a really good thing to do during your talk, just for you, just like make you feel like, okay, I'm getting through to people. But in terms of the actual interaction, people don't typically ask questions during a talk in a conference. So no. And yeah, you don't generally have enough time to do experiments like asking people in the audience concrete questions like so I wouldn't do that. As for the last slide of the talk, I don't think it matters all that much, to be perfectly honest. By that point, people are happy the talk is over. Like, I mean, they're like they're like happy if you give a good talk, they're happy they learned something. And they're like, yes, it's fine to, I mean, you could have a slide where you summarize, you put your contributions up again, that's fine. You could have, again, one of these what else is in the paper slides. Sometimes I just end on that. You could have a slide where you advertise your research group or say, like, I don't know, we're, looking for people to keep working on this project. If you're interested in this project, come talk to us. Those are all fine things that, sort of advertising-y kind of things to do. But you don't have to have some super strong conclusion. I think it's fine to have one of those kind of slides. Yeah.
Ideas. So what do you think about using AI? The text on the paper or upload it so that like we can
Yeah.
ideas.
Right.
Maybe actual maybe that's reviews.
So I don't personally have a lot of experience using AI for preparing talks or papers. I know that I think that for papers, it can sometimes be helpful with students writing if they have already drafted some text and they want to get an idea of how they could improve the flow or coherence but it generally, I mean, I don't have a lot of experience with it. I'll be honest with you. So I'm not the best person to ask. I think it could potentially be useful, but yeah, I prefer that my students learn how to fix those problems themselves, and then yeah, if you really need help, you can. With a talk, it's a little different. So sometimes my students have used like AI image generation, for example. Sometimes you have then it's quite useful because you might have some concept you're trying to get across or something, and you want some somewhat humorous image that like merges two things that don't normally exist. I don't know. It's like, I don't know, like maybe we're doing a lambda calculus for Rust, so we want to have some image that has like a lambda and a crab in it or something. I'm making this up, but that kind of thing. My students have used it for things like that. But that's like that's a very specific use case. In terms of actually structuring things, I think you need to figure out what you want to say, really, and I don't think AI is going to help that much. Yeah. No. I mean, yeah. Okay. First of all, the experts are not expecting that you're gonna, fully explain all the details of things in your talk. Are you talking about in the talk or in the paper? Oh, in the paper. Yeah. No. I mean, also no, because you're gonna. I mean, obviously, if you say something that is in the key idea is that it's simply not true, or that it's like a gross oversimplification, that's a good thing to mention, like in a footnote or in a parenthetical comment or something. This is an overly simplified story for purpose of a presentation, C-section, whatever, for the full story. Okay, that's certainly a good thing to do. But often you just present things at a higher level of abstraction. You're not lying. You're just not giving all the details, right? And then I don't know. I mean, the expert reviewer will read on and they'll look at the technical part. That's perfectly fine. It just occurred to me there was not actually somewhat related to this question, sort of. That's something I meant to add to this talk this time, and I forgot to do so. There's a section in. Sorry, I know but I'll just finish this one point and mix up. There's a section I've been adding in papers recently, which I find works really well, and it's somewhat counterintuitive. And this is a section I call non-goals and limitations. So I often put this section at the. It's not a section. It's like a paragraph at the end of the introduction, after the statement of the contributions. I'll often have this paragraph called non-goals and limitations, where we explicitly call out the limitations of our own work, the things we're not both things we're not trying to solve, like maybe we're not trying to handle concurrency in this paper, or limitations like our type system, is limited and it doesn't support high order or something, right? I don't know, whatever it is. And reviewers love this. It just really helps them because often when I'm a reviewer, I'm reading the paper, I'm thinking, what are the limitations? Please tell me the limitations. And most authors don't want to give up their limitations. They don't want to tell people. But if you just tell the reader, the reviewer, then they're not reading the paper constantly, critiquing everything to figure out if it doesn't work, if something works or doesn't work. So it really helps to just like set it's like it displays confidence. Like we think this paper is really good, even though we don't handle these things. And for now you know what it doesn't handle, so you don't have to go searching for that in the paper. And this is something I sometimes do in talks as well. I guess one more. Oh, okay. So yeah, as I said before, I think you need to make sure the introduction is clear, right? So you need to make sure you give enough time to give a clear introduction. If that means that the introduction has to take a little longer than, like maybe it still takes 8 minutes, even in a 15-minute talk, that's okay. Like the introduction is really, really important. People need to understand what problem you're solving, what the gap is, what your claimed contribution is. So I wouldn't reduce it too much. But of course, if you can explain it a little more quickly and still get across the main idea of the introduction, then sure, you can try to compress it. Thank you.
Yeah, I have a quick background about lunch. Y'all want to grab your lunch out here? And go that way. There's 2 hallways. Go down some stairs. We have a
you.
You got it.
Yeah, we're fine. Can I get rid of that?
You'll want to bring the, oh, you can,
No.
you talk from here
Where else?
later.
I don't have a, yeah.
Not power to get through.
Yes, yes,
Like, do you have your mic already?
yes.
It's on.
Comrade, I can't change. I can't change.
Try clicking. And
What's-
now try the arrows again. Okay. And you're not getting any echo, just say something.
Hello?
Okay.
Testing, little bit.
Okay, that's good. That might be right. Yeah, if I don't want to de-mic Philippa, so can we get a second? Sure, but I'll be quick. Okay, hello everyone. Welcome to the second section that's happening right before the break. So now we have someone you're already a little bit familiar with from the panel, Philippa Gardner, a professor at the Department of Computing in Imperial College London. Her work focuses on formal methods for analysing modern open software systems, developing sound mathematical foundations, and well-engineered tools that scale. Philippa completed her PhD thesis in Edinburgh in 1992 under the supervision of Gordon Plotkin, then moved to Edinburgh in 1998 to work with Robin Milner. She joined Imperial College London as a lecturer in 2001 and was promoted to professor in 2009. She's won several awards. I'll highlight two: Fellow of the Royal Academy of Engineering in 2001 and the British Computer Society Lovelace Medal in 2024. Please take it away, Philippa.
Hello, everybody. I don't normally do a panel, then immediately go on to this talk. So you know me all already, and hopefully you'll get to hear me, get to know me in a different way from this talk. This is my excuse to put up some of my some wonderful people that I know, which is Tony Hoare, Robin Milner, now not with us. Tony Hoare is frail, but basically they've been founding fathers of our field, and going all the way back to Alan Turing, there's been this real message: what does it mean to verify our software? And actually they don't just mean that, they mean what does it mean to specify and validate or verify their software against some specification. And when I was starting out, I was doing results on pen and paper. And there were colleagues of mine working on proof assistance. Randy Pollock did something called Lego. All those rock people were coming over and being part of the Edinburgh infrastructure. We were having talks all the time. So people were working on these proof assistants, but in this very specialist way. It wasn't this natural thing that you used in order to prove your results. Whereas nowadays, you guys, you're needing to know this stuff and work out what you like within this world, because now things are mature. And my particular world is that I personally like to work on mathematical techniques and well-engineered tools for reasoning about open modern software at scale. And my side of it, I've come from the theoretical world, my side of it is that I'm getting the maths right, which means I'm doing compositional analysis techniques. And then others, including others in my group, are doing well-engineered tools to work out how to make it happen practically. I am not that big span of a person that can do everything. I do the theoretical stuff. And in particular, I do a lot of work on the specification of language standards, libraries, more ad hoc programs. And what does it mean to specify? What does it mean to validate that specification? When it comes to language standards, there's a different notion of validation to when you've got programs where you really can fully verify. So what is the is the argument to say that what you're doing makes sense. So first I'm going to talk about WebAssembly. And it just happens to be the language standard that I'm working on at the moment. Most of what I'm going to say can refer to other standards too. Now, this started with Gordon Procklin doing structured operational semantics. Robin Milner did his mathematical definition of the functional programming language ML. We then have these mature proof assistants happening, and so we can do mechanized language standards. But we haven't really been able to do them. What's been happening is that these mature language standards are out there, and then awesome people are doing large bits of C or Java or JavaScript. So for example, one of the important ones is the Concept project, where there's a large part of C, but it didn't affect the language standard. It was done afterwards. And I did some work on JavaScript. But things have changed. And they've changed with the WebAssembly language and with Anders Rosberg as part of this WebAssembly language. And now next generation Conrad Watt as part of this WebAssembly language. And the point about WebAssembly for me is that it has a formal specification. And so, you know, now this PL world can start working. And boy, aren't we working. We're working very quickly and things are happening. So Conrad was sitting in my fourth year, has been sitting in many of my courses at Imperial. We've known each other since Conrad was in his second year. I can't believe I am standing here giving a talk at PLMW in Singapore, where he is an academic. Normally I don't come to Uppsala because I'm teaching. There's no way I wasn't coming for this talk. And I am going to so not like my 9 o'clock lecture on Thursday. It's going to be an absolute nightmare, and it's all his fault. But what he was doing, he was learning about some work that I and many others were doing on JavaScript mechanization in the ROC theorem proof. And he then went for his industrial placement to Google Munich with Anders Rosberg and learnt about the fledgling WebAssembly before it was anywhere near being published. And that turned into his PhD, which he did at Cambridge, working on Isabelle rather than ROC. And he still prefers it. But in particular, this is absolutely wonderful. So, you know, this is what you guys in this new generation can do. So Conrad was able to fix problems with the formal specification and the type safety result because he was working with Isabelle almost at real time. And he found things that were wrong before publication, so they were right. And they were right at publication, which meant that this formal methods agenda didn't start badly, right? That would have gone down well. But basically, he and I have come together and done this large project on WASM cert in Isabelle and ROC, with Rao being a PhD student that's just finished with me. And one lovely thing is that we can do module instantiation. We can only do it, so we can do the type safety, but also, you know, it's much more complex. We can do module instantiation. Now, one thing WebAssembly is, it's a language with modules like Robin Milner's modules, purposely, and just Rosberg created them that way. And Robin Milner was talking about type safety and module instantiation all those years ago. and he was doing the work by hand. And when I was a PhD student, Mads Tofte, who, by the way, is the guy that persuaded me to go to Edinburgh, and told me not to be such a blithering idiot when I went up. Mads Tofte and Robin had, for the second iteration of the standard, had realized that there were problems with the module work. And in particular, I grew up as an MSc student, as a PhD student, knowing that Mads Tofte and Robin Milner were working between 6 and 9 each morning, trying to sort out modules before the book deadline. And they managed. And they did it by going, right, we have our normal day, but this part of the day, we're going to work out how to solve our problem. And they did, but also that shows the steel that was needed to overcome the problem that was there. So for me, it's just a tiny little thing, but when MSc students with both Conrad and with me ended up doing this module instantiation result, this was a big deal as part of my history. And also, I think it's a big deal from the point of view of the sort of work and the community, because part of our jobs as academic, what's it mean to get it over the line? So in industry, you have to do that all the time. But in academia, you can write your lovely papers and not go all the way with a subject. And for me, I don't know why, I judged it. I just turned quite strong about this, that I wanted to get this thing over the line. And we did. And it was nice. Because who else is going to do it? This work's too fledgling at the moment. Yeah, it's not something that is very normal to do. We've gone on. There's now lots of applications on top of WASM Cert. The first one being Iris WASM that Conrad and I did with the Aarhus guys, including, well, the PhD awesome student was Ina. And this is now a big, large project inside Aarhus with a few things going on. But the world has changed. This lot is now out of date. We've done WASM 2.0. We are choosing to maintain it for our users at the moment. We actually have users. Yeah, and so we're having to maintain, and we are, but it's now completely out of date. And that's because of the new work that's come along called WASM Spec Tech, which is a new way of doing language specification based on formal methods. But it needn't be based on formal methods, but that was part of the motivation. And it's us lot, not Ina, not Ina, but the rest of us, Duck Young, some others you'll see on the next slide. And basically, some awesome things have happened. Now, I don't know whether what Derek talked about in his 90-minute talk, but I've heard him give a talk on how to give a talk. And he goes, right, you've got to do the kapow bit. So in the spirit of Derek telling me and the rest of the audience to do kapow bits, I've put some kapow bits in. So here's one kapow bit. So WASM Spec Tech was adopted by the standard in March 2025. I'm going to tell you about it in a minute. And the other kapow thing, Anders Rosberg actually used it, this new process, to do WASM 3.0. So this is what I mean, that the other stuff is now out of date. We've got to port everything we've had before to this new place, and I very willingly want to do this. It's the part of the work was designed just so that we could. But, you know, Sokyung and Anders Rosberg and a whole gang of us, but these two in particular, they've got it to WASM 3.0 now. It's been extremely fast, extremely good. Here's the gang. I'm just going to flash it up. The other one to mention is just Sam Linley because he happens to be here. There's others. I can't do them all. Anders Rosberg's going to be here. Suk Young's here. Conrad Watt's here. Anyone else? I don't know. Yeah, that will do. So let me tell you a little bit about what WASM SpecTech is doing. So WASM's basically, it's on the browsers, it's in most of your smartphones. So here's some browsers, and these are the original browser companies that were doing this stuff. And basically, we've got WebAssembly with lots of things. And out later, we've got Isabelle and Rock. Later, but it was quite tight because of Conrad. And if we look at this bit, basically what you need in order to get it through the W3 standard is that you need formal specification, prose description, test suite, reference interpreters. Formal specification is extremely unusual. The others are normal. And there's actually, the way it works is that Andreas Rosberg, Conrad, and some others basically write a formal specification, and then the other stuff piles in behind it. And then we have the WASM cert work off to the side. But now we do something different. We've got a domain-specific language in which we write the WASM stuff. It's a little dependent type theory with people arguing as to what it should be, what it should contain. And from that, we have automatic generation of the formal prose in LaTeX, the formal specification in LaTeX, the prose testing, reference interpreters, and not yet, but about to happen, the mechanizations. And in particular, what's just happened, but it's not published, is that as well as from the DSL, you do the normal things and the formal specification that's not normal. As well as that, we also generate the mechanized definitions. And Conrad's doing Isabelle, I'm doing Rock. Joachim Breitner, that was one on the list, is doing Lean. Sam, as internal into the Lean FOO, and Sam is doing AGTA. And basically, we're getting this ecosystem of all these proof assistants. So, and we're trying to understand how things will go between each of the assistants. And we're also trying to understand what sort of structure we need in order to make the step to individual proof assistants as simple as possible. And this is a sort of side project is going, oh, well, we've got this wonderful place where we can do these. We've got an application where all the people from the proof assistant world want to play. So now, which proof assistant is going to be better, which worse? What does it actually mean to design the proof assistants for the future in order to do good language standardization? Well, that's your guys' job. Yeah, it's that next place. So we're assessing this place, what's happening right now. And Tai Chi was an MSc student. Diego was my MSc student and then PhD student. This gang has done the next path. There was some 2.0, not SIMD in Rock type safety proofed. And we're not going to publish until Conrad hurries up. But what? No, not in the SpecTech work. No, that's what I mean. No. So in there, I'm teasing him unmercifully. You know what actually happens is you've got these MSc students and PhD students. One comes every so often, and what does it mean to have a good fit? And these people are the right people to do the job. It's actually quite hard. So basically, we've done the work, and Conrad's got his group of people now, and he will be doing the Isabelle, and we will make sure we publish together. I mean, that's very important. Sorry? He will tell me what to say in the next talk. So So this is language specification. And, you know, when we were starting this work, we didn't know where it would go. And it's gone to this place that's actually really rather extraordinary. The next thing I want to talk about is compositional verification and true bug finding. For those of you who know, I'm basically talking about the world of separation logic and the tools for separation logic. And the way I'm interested in it is in the form of what is the specification of a function and what does it mean to verify a function or verify that specification or find errors. So the separation logic guys are Peter O'Hearn and John Reynolds. John Reynolds is not with us anymore. And basically it's modern Hoare logic developed by Hoare. And the idea is that now you can verify properties of heap manipulating programs in a local composed way, whereas before it wasn't, and so things blew up as your memory got bigger. So in Hoare logic world, it's very good at reasoning about the global variable store. It's not good at reasoning about the heap. And separation logic helps here. And there's been lots of work by many, many people on this whole world of separation logic and various tools. There is, you'll hear a lot about the IRIS framework in these courses in this week based on this sort of work. Also, there's Meta's Infer project that basically was extremely important at the time. It was the first analysis tool of its type to get into the CI. So you've got errors going to every general developer, and the general developer had to justify whether or not they ignored those errors to a human. And there's some very new work in called incorrectness separation logic that's looking at finding true bugs rather than doing verification. And that work is sort of fits better with the tool work that was going on inside Meta. And I'll explain a little bit as I go. So the new generation is Jules Villard and Azalea Rudd from Imperial doing this work. And what I've done is looked at the techniques working in many of the separation logic tools. Not the IRIS framework, in the tools such as Meta, Verifast, Viper, my one's Gillian, that sort of work. And basically, we're working with symbolic execution. So you know about operational semantics. One can think of it as just an operational semantics, but instead of working with concrete values, you're working with symbolic values, which are logical expressions built out of logical or symbolic variables. And you provide a static analysis of what's going on with your program for arbitrary input. And you don't need to know this, but symbolic state is just going to be program store with variables having symbolic values, meaning these general values. Symbolic heap, so you can have different versions of which bit of the heap is symbolic. Do you choose the addresses? Do you choose not the addresses? That sort of thing. And you've got these path conditions telling you what's happening at the branching. So for example, when you're in this general place, when you get to a branch, you've got the Boolean, one side of the branch, the Boolean is true, the other false. You just keep this information in that pi hat. Hat just meaning symbolic. These first order path constraints are checked with SNT and SAT solvers. And in this world, you're manipulating the structures using consume and produce operators. And compositionality means it's possible to analyze a function by itself, independent of any of the rest of the industry code base or GitHub code base. You don't have a main anymore. And the intuition for this is Hoare logic is you have a precondition, the command, and a postcondition. The precondition captures the resource you need in order to do the job. If your function is doing a tiny update on one cell, you need that one cell, you do not need any more. And the specification says that. You only need the resource you need for the function to go. And I won't be going into it today, or I will a bit. We can do this in a unified way where the correctness world and the incorrectness world are unified. I'll hardly say that. So this is the only bit that I'm doing that's technical. Here we've got a Hoare judgment. Instead of a triple, it's a quadruple. That's only because of the unification of the two styles of reasoning. You've got precondition, two postconditions, giving an okay result. In normal separation logic, you would just have this bit with the okay without the errors. And then incorrectness was focusing on the errors. So that's, and now we tend to split them apart. You don't actually need to. And for those of you who don't know what incorrectness separation logic is, it means given any state here, you can find a state in the precondition such that you get to the postcondition. And so this is what I mean by true bug detection. If you find an error, you've got a state where you get to that error. It's a theoretical rule, excuse me, a theoretical concept. It doesn't mean that in reality, you practically, do you get there, do you not get there? That's a different type of argument to do with what a coder wants. This is a theoretical result about the fact that the states here are reachable from here. And the work that we've done is we can provide algebraic function interface between what's going on with the specification and what's going on with the tool. And what I mean by that is that the meaning of what's going on here with the function has got nothing to do with the tool. And that's, there's been lots of work on foundations of how these tools are working, but never where you've got this separation of what's going on with the meaning of the function and what's going on with the tool. So here I've just got a rectangle to illustrate this symbolic state. So this shows the level I'm doing this, right? I was just a rectangle. And the name of the game is what does it mean to match this part of the precondition with part of this state. So you can match if the function is it makes sense. Excuse me, I haven't said you've got a symbolic state and you've got function call here. So basically you're calling this function, you've got this precondition, you are matching this precondition to part of the symbolic state, doing whatever substitution you need given by this theta. You're consuming it. That's what the consume operator is. It's match and consume. And then let's assume we're in the okay state. We're adding on that. Well, it doesn't matter. You add on whatever is here to whatever is here, giving the substitution theta. And that's called produce. And we've got general correctness results. That you have a frame property. This is actually where the frame property for sequential computation is needed. It's to do with the function. And you have soundness. And it's general in the sense that we are not working with, we can work with arbitrary memory. And just to illustrate, I've said that there was this unified approach for incorrectness and separation logic and correctness, just to say the same thing is happening with correctness. So this is a normal Hoare triple just extended to be okay or error. And you match here by implies, whereas before you were matching by sat. So by implies, I mean, you've got a pi hat here, and the pi hat here has to match has to imply what's going on here. And the point about this, the Powell thing from Derek, is function specifications are independent of the CSE semantics. And this is crucial. Here you are in a big industry code base or GitHub. You don't care which tool is doing the work. The thing that you might be interested in are these function specifications. You need to know that the meaning of the function specification, that there's some ground meaning given by a semantic relation associated with separation logic. You don't even need to care about a particular set of proof rules. You only need to care about its meaning. So this means it does not matter whether you're working with our tiny CSE tool or Iris or Infer or whatever you're working with. If it's grounded on the same separation logic, it makes sense to be used somewhere else. So I think that message is a message that is sort of quite important for these style of tools, and something we need to concentrate on perhaps more than we have been doing. Now, what's going on is that we've got algebraic properties for these consume and produce functions. And with these algebraic properties, if they hold, then the correctness result holds. And now I want to implement these consume and produce functions in a real tool. And as long as the correctness, assumed properties of the consume and produce operations are working, including the assumed properties associated with matching, if they are holding, then we've got our soundness result. So we've disconnected what we're doing in the implementation versus what we're doing in almost the analysis tool specification or the consume and produce specification. So I think I have caught for now. Yeah. So thank you. So we have this Gillian tool. It's a Gillian platform because it's a parametric on the memory model we're working with. So we're able to work with C or JavaScript with very different styles of memory. And what we've done, we've got the match consume and produce algorithms inside the tool. And then what we've done is turn them into first Haskell so that we're just going with the precise things of what's going on with these operations rather than with all the optimized versions associated with the tool. So we've gone to the essence of what they are. We've then got pseudocode, and we've proved that the pseudocode satisfies these properties of the consume and produce functions. Now, is this a good way of doing it? What is the right way of doing it? Not sure. We're exploring. But this is a way of trying to bridge a gap between what's happening at the implementation and what's happening with the specification of these consume and produce functions. It's just the same as what's going on with language design. You've got language standard, you've got language implementation. What does the implementation, how does the implementation justify that it conforms to the standard? It does so via testing. Yeah, what does it mean here? That a tool is an implementation of an analysis specification. This is what we're doing. We've done several of these. We've done JavaScript, C, and instantiated. We've actually done Rust now, but we've still got so much to do. So that got published in PLDI this year, but we've still got much to do. So I think it's on good. And lots of applications, and in particular, what I like to do, I think people all have their different ways of doing it, but I like getting to the edge of industry. So I like, but I had this wonderful experience, very kind of them. The AWS people talked to us, and they found some code that they asked us to do. And this code was, it was quite a critical part of what they were doing. And the developers had written first order logic formulae in the comments of the code. And they were doing runtime checks of these first order formulae. And what we did was verify the code, finding mistakes, some of the structure. He was going against the structure of the data structures, and we corrected, changed that too. So basically, we were using his specification, first order specifications, and then going to the separation logic place to do the analysis, coming back out to the first order place where he was. And in particular, he had done both JavaScript and C implementations. So we did the verification of them as we could. And so that was really informative time for us. But I only need to do it once. It's not my job to use my tool lots in industry. That's not, my tool is not that sort of tool. It's to understand the ideas. And the Gillian implementation almost conforms to the CSE specification. The reason why, well, Gillian came first. Many ideas in Gillian got into this CSE foundations, but as part of going to the CSE foundations, we had a lot of people arguing away as to what the right choices were at that foundational level. And now, you know, we're happier in the foundational level, and the Gillian choices are not quite right with respect to how we chose. So what we've done, we are publishing this in Uppsala. Simon's going to give a talk on Saturday. We've done parametric CSE before it wasn't parametric, and we've done it in the ROC mechanization. So the foundations are very, very solid. And I've just got a PhD student whose job it is to do next generation Gillian. And how are we going to do next generation Gillian? Are we going to go to Haskell? Are we going to go to what we did Gillian in was OCaml, but a former student very much wanted to go to Rust, and at the time others didn't let him. So, you know, should it be in Rust? You know, where should one be? Well, actually, think about it. The person who's going to choose is the PhD student, because the PhD student will be doing the work and having the favorite programming language. So, you know, there's, you guys, you've got so much opportunity of how to be active and creative early. You know, you're making the choices, whether it be theoretical choices or practical choices. So I'm not going to give, I've got a video of the tool. I'm not going to do it. I'm just going to start it for literally 2 seconds because I've got one more thing that I can talk about. There. So if we did the sound, it would echo. We tried it out earlier, so we're not doing the sound. So basically, just to say, the tool is actually really cute, and it's really cute because of Nat. And he has done debugger for symbolic execution that he's been able to do sort of almost separately from Gillian. So he's trying quite hard to provide a general tool for debugging. And that's not where my world comes from. That's a PhD student as an MSc student being interested in. That's worth saying. So Sasha used to be my PhD student. He's now with Azalea. And what he's done, he did an MSc project on debugging. He then did 3 further MSc projects. The third one, Nat, took off. And it turned into something that's going to be his PhD. And we managed to get him to stay and do a PhD, not take an engineering job at Meta, even though they were not hiring and they still hired him. So we're very, very lucky that Nat is here. But this will be short. So I'm going to say a little bit about the last thing I work on. I can't tell you everything, but one of my loves is actually doing theoretical work. And I've done a lot of theoretical work on reasoning about concurrent programs using separation logic. So I'd like to say a little bit about that. So it's compositional verification about concurrent programs. And by that, I mean shared memory concurrent programs where there's competing threads on a part of the memory. And compositionality provides 2 things. It provides proof scalability. It could be thread compositional or functionally compositional. And it also provides proof reuse. If you get to the right abstraction level with your specification, then you can decouple what it means for an implementation to satisfy the specification and what's it mean for a client to use that specification. And at the time, there was a lot of work, there was a lot of challenge as to how to get to that right level of abstraction. So there was some absolute breakthrough happened. And it was down to these guys, Pete O'Hearn and Steve Brooks, who invented concurrent separation logic. And this for a long time was where they were thinking that the separation logic was really flying. We now understand about functional compositionality. At the time, it was happening here with the concurrent separation logic. And what they've did was thread compositionality. So something parallels something else. What's it mean to statically verify both parts and put them together in a specification? And they did it with programs with synchronization primitives. And the previous work of many people, the big ones are Wikigrees and Cliff Jones, they went on the way, but there were all problems to do with the compositionality, and these guys got it up to a point because they were doing it with respect to synchronization primitives like locks, rather than so fine-grained programs like spinlock couldn't do. Maurice Hurley, he gave us abstract atomicity in his work on linearizability. And that works great, but it works great up to a point. So what he did was show if you've got a linearizability property, I'm not going into it, if you have a linearizability property, you can work with sequential specifications. And you can think about it as if it's a sequential specification. That works for many things. Counters, for example, doesn't work for locks. The blocking of locks doesn't work. And I've done some work with these 2 guys, Matt Parkinson and Thomas Dinsdale-Young. And I have an internal grin going on. It's just brilliant, brilliant time. Thomas Dinsdale Young made me get into this field. He was a most amazing PhD student who's now in industry. And what we did with logical abstraction, we could do thread compositional reasoning for fine-grained programs, you know, not just the synchronization primitives. And we can do it at the right level of abstraction so that we have two-sided specifications where implementations satisfy the specifications used by the client. That's possible with this work. This led to something called the Views framework. I am very proud because we got a Test of Time award for that. We had these are wrong dates. This was 23. This is wrong. Excuse me for that. And it was Popple 23. So I don't know where that's come from. Sorry. You can see I'm bugged by it. Details. This I was really proud with this because we had our paper rejected 3-4 times. It was really, really hard to get stuff published, but because of that, we got it better, you know? So don't know if I think one needs the stubbornness to keep going, yeah? But the problem with it, and it's a serious problem, is it was happening during his PhD. So what does it mean that a PhD student has confidence as the papers are being rejected? It's a hard thing to understand. He knew the work was good because he had enough confidence to know that. And the other thing we did, we still hadn't got functional compositionality. We still hadn't got the right level of abstraction. And we did it with logical atomicity. And these two pieces of work were part of a huge big story to do with getting to the IRIS framework that's now the thing that's used a lot. We've done some newer work, I mean, here. And what I'm doing now, I've spent the last 2 years with wonderful MSc projects. And the point is to consolidate, to understand why this is hard, understand what does it mean, where does one go next. So I'm sort of, that's where I am now, and where does this go? Well, it will go somewhere. Nearly. There's 2 more slides. Yeah. The point about this is specification of concurrent programs at the right level of abstraction. I said 2, I don't mean 2, but they're quick. Sorry. Why do I have this green and gold lame chair in my room? The reason why is because of Thomas Dinsdale Young, who has the tie of the same material. And basically, this is his chair that is normally in imperial blue. And instead, it's in gold and green lame because he likes to be a bit rebellious. So the chair is very old and decrepit. It doesn't, it's not sat on anymore. It just sits in a corner. But that just shows, you know, what's going on. You know, if one's getting it right, the PhD students are treasuring what's happening as part of doing their PhD, but also the supervisors are too. The last slide I want to talk about for concurrency is this one. I will not say very much, but just to say this was done by Ilya Sergey, who's the general chair of ICANN. And he was very much part of this story to do with concurrent separation logics. This is his bit. That's the blue is the bit that was ours. This now has gone to IRIS, and now it's a huge iris thing. So, you know, there's no, that's where this is work is at the moment. The iris thing is to do with a certain way of doing it inside rock. So what I'm trying to do with these MSc projects is to go, well, you know, there's lots of other ways. What's the right ways? How does one explore and think? So where is this going and what happens? You can stay within that rock land where the choices have been made, or one could go somewhere else and start struggling with what next. So that's where I am at the moment in this work. So basically I never knew that my research was so coherent. It didn't feel coherent as I was doing it at all. I was just doing sort of things that I found interesting. But it is about specification of various forms, whether it be language standards. I say libraries and ad hoc programs, but I'm meaning more than that. And I purposely didn't say that before because I wanted to first tell you what I'd done, which was, you know, we've got the specifications of the concepts inside more than one analysis tool, in that these consume and produce functions really, you know, I gave you Gillian, but Viper and Verifast also would work in, and Info would also work in this way. So how should one think about specification as part of our ecosystem for understanding our software infrastructure of the future? This, for me, is actually where my career went without my quite realizing it at the time. Thank you.
That's great. Thank you very much, Philippa. I'm sure you all have questions, but given that we're slightly over time, maybe Philippa can stay here and we can have people come up if they're interested in asking questions. I'm sorry to have chased you a little bit across the stage in those last few seconds, but it was very good. Thank you so much again.
Thank you.
All right, we now have a break. We're still going to start on time. So back here by 4 for the next session, which is how to get the most out of a conference. Is that it? Or is it the graduate panel? Excuse me, graduate student panel first, but back here by 4 p.m. You okay?
Yeah, absolutely. Hello.
Thank you, your mic.
No.
Good. Thanks so much.
ASMR with a mic. Oh, wonderful. Okay, this is a very long session. Why don't we all get up, stretch a little bit? So just like, I think you can flip your desk up. Yeah, don't be shy. I'm gonna stretch with you. It's a very long session. We gotta like get our brains moving, get our bodies moving. Yeah. Stretch any way you want, but if you want to follow me, you can kind of, cross your arm. Be careful of your neighbor. Cross your other arm the other direction. Yeah. Careful. Maybe do a little bit with your neck, side to side. Maybe hands behind your back. Stretch it out, stretch your shoulders. I would suggest, the quad stretch, but that seems hard for balance, so I won't suggest that. All right. Okay, hopefully everybody feels ready. You sit back down now. Helps me a little bit to stretch out. Okay, cool. So I have been to a lot of conferences, so I'm going to be talking about how to make the most out of conferences. I gave a little bit of an intro already on the panel. I've been for very many years of my PhD, so I've now redacted how many years it's been. But I was like you, was attending PLMW way back in 2017. And so I've been here for a long time and attended many conferences, as I've already mentioned. Right, so I probably should have actually given this caveat during the panel. So advice in general doesn't work for everyone. My supervisor's favorite saying is basically like, ignore all advice given to you, which is kind of strange because that means you would ignore that advice. Don't think about it too hard, right? So I'm going to be giving a lot of advice in this talk. You can feel free to ignore all of it or take some of it or just pick and choose or augment it to your purposes. So I do want to give that a little bit of that caveat. But if you're like me, I'm kind of like an advice junkie. I love reading other people's advice. I feel like it's, it's a way to like fix my life. So if you want even more advice, there have been other great renditions of this talk by other people, Joe and Sam at PLMW and ICFP 24. They're fantastic renditions of this as well. Okay, so I want to talk about conferences, right? So conferences you might think of as kind of three main components. There's a lot of research talks, right? A full schedule of them, right? And things associated with the with the conferences like workshops and receptions and things like this. And there's a lot of strangers. But what I'm going to encourage you from this talk is to actually flip this perspective, right? So focus on the people, right, that are at the conference. There are a lot of friends, potential collaborators, potential supervisors. And to make the schedule your own, right? Don't focus on how full the schedule you can make it, but how you can kind of sustain it over a long period of time. And then we'll talk a little bit about how to sort of attend and absorb research talks. And my emphasis on people is ultimately because conferences are a way to engage with a particular community. So here it's going to be ICFP and UPSLA, two big communities, one much bigger than the other. And to effectively engage with the community, you really need to feel a part of a community, right? So that's why I really, really emphasize the connections you make at conferences. All right, so we'll start with our lots of strangers. You might be wondering, why does it even matter? Why do I have to put such an emphasis on people? If you want to think short term, it'll make your conference experience a lot more enjoyable. You'll have people to hang out with during the breaks, go to dinner with, lunch, etc. But overall, at sort of a high level, you'll get a lot more long-term benefits from engaging with people. So one of them is building up a support system, as I mentioned, and as many of the panelists mentioned, right? This aspect of going through the PhD together, making that community early on was something emphasized. And then again, as I'm sort of nearing the end of my PhD, I'm thinking about opportunities for the future, right? And so you can sort of build those potential opportunities for your PhD or afterwards, kind of early on. And then again, we talked about collaborations. Best way to make collaborations is to meet people. So of course, the reason to build a support system is, of course, nobody gets through life alone. Again, in graduate school, I found it so helpful that I have so many friends going through it with me, not only at my own institution, but across institutions, right? I've kept up with so many people from conferences. Even that very first PLMW, I still have friends from then. It's such interesting the way that loads in, but like this is, me at the last conference I attended, ICFP in 2023. And I decided to just start taking pictures of people because it's a great reminder of all the people I've met and it really just emphasizes like how much the people matter at a conference. More opportunities. So at a conference, when you talk to people, a lot of people are, associated with universities and our academics, but there are a lot of people doing other things, right? So you can learn about completely new potential careers. We had the job panel for that as well. And there's also, if you are curious about people beyond what they do for work, there's also potential to discover all kinds of new hobbies. So when I was an undergrad, I had no idea what professors did, right? I still, to this day, remember talking to my undergrad advisor and being like, oh, there's conferences in PL? What do you do there? That sounds like fun. Do you all just, talk about these interpreters that I've been learning about? So yeah, even as an undergrad, I didn't really understand what a professor's career is like. And so research conference is a great way to learn that firsthand. There's also, maybe as a hobby, a strange obsession with t-shirts at conferences. It turns out Jane Street is not a t-shirt company. Although they seem to be. So this is another thing, you can collect them all from our conferences. And then finally, as we mentioned from the panel, and I'll just emphasize again, a great way to start potential collaborations is by attending conferences, giving talks about works in progress. That's how I was able to start one. We even started working while at the conference together, right? And then, of course, this also has the added benefit of building up your support network. So for me in particular, I met my supervisor at ICFP, as I mentioned, when he was still a graduate student, but had been hired to start a tenure track position. Yeah, so how do you meet people? Good way to start is to start with your peers. It'd be great if we were to gather up a bunch of people who are just starting out, maybe running some sort of workshop to get them all together. That would be great. That would be really good. Oh yeah, that's what we're all here for. We're here at PLMW to meet each other, to start building up our support network. So I'm going to give you a few minutes to talk to each other. You've had the icebreaker in the morning, but let's do it again just to reinforce that. I'll give you a starter question, but you can honestly just talk about whatever you like. So like, what's your coffee order? Or if you don't drink coffee, what kind of drinks do you like to order? So I'll give you a few minutes for that. Okay, let's come back. Usually it's much easier to get people back. So this is great. Very active, big group here. That's awesome. It seems like you all are really getting to know each other. That's great. So one thing I will note is that, a great way to expand beyond PLMW is the people who have organized PLMW. So a bunch of us, just pictures here. I kind of had to layer them up. But a bunch of us here participate in PLMW because we care about building our community and mentorship, right? And so I'm just gonna, advertise that, hey, all these people you've seen today are open and willing to talk to you. And that's how you can sort of start expanding beyond PLMW, just starting from PLMW and going outwards. And then I'm going to give you a little bit of a challenge. I did forget my gold star sticker sheet, but I have it. It's just in my hotel right now. But if you introduce two people that maybe you've met at PLMW and then meet somebody at a coffee break, you then introduce those people, I'll give you a gold star sticker for that. I might run out quickly. We'll see. Okay, so I'm gonna try and go a little bit faster, but you'll see during the coffee breaks, sort of conversation circles start to form. And so I'll give you a little bit of advice about that. So if you're, conversing with people, especially from PLMW, try to always make room for other people to join, and be confident joining other groups, right? Always try, you might be mid-conversation, but always try to kind of give them a chance to introduce themselves, maybe let somebody finish a thought, but then you can say, hey, just joined, you mind introducing yourself, or start with yourself, right? Always introduce yourself to new people. And so during those conversation talks, circles, you might have some small talk. So, you can ask questions like, what's your research? What did you think of some talk or keynote? All these boring small talk. What I suggest to you instead is to ask questions like this. So what's a photo in your phone with a chaotic backstory? If you were a fish, how would you grow back your legs? What's an animal you wish you could have as a pet? Ignoring all the sort of ethical concerns with that. Assuming it is okay to have pets in any kind of pet. And what's something you wish you could have touched on in your talk? Okay, that's actually a very good question. And you will get a lot of people from talks, especially from the Uppsala talks, because they're only 12 minutes long or something. Yeah, you'll start a good conversation with that question. And finally, I will tell you that strangers are a lot like spiders. They're more scared of you than you are of them. It's hard to get through. People are very happy if you come to them, excited to talk to them, starting a conversation. Trust me of that. And of course, always keep in contact. I will give you my contact information at the end. It's a good way to continue keeping up with your support network even beyond this particular week. Oh, and finally, okay, I guess I have a lot of advice here. Make a website. People need to be able to contact you. Something as simple as a photo of yourself, if you feel comfortable with that. This is me. This is where I'm at. Some stuff I do. Here's my email. It's becoming harder and harder to find people's emails, I find. Because a little bit of a embarrassing backstory, I did not have a personal website when I attended the conference where I met my supervisor. And he found some really old WordPress site that I had to do for my first year of undergrad. And that's how he found my email, and that was extremely embarrassing. So have your own curated website be the first thing that comes up with your name. Okay, so kind of mentioned the three components of a conference, which was people, time, and research talks. So let's talk about scheduling your time. What was this trying to say? This is kind of like don't dead open and don't attend. Oh, okay. Don't attend every talk. So you might have attended every talk in PLMW, and that's a good way to start off. But it turns out that the rest of the conference is going to be organized into sessions. Sessions consist of a lot of related talks, and you should really be using that to your advantage, right? So if there are sessions that you don't find as compelling, this is a good opportunity to get some rest and to skip that part of the conference. Might be wondering, well, which sessions do I want to actually attend instead of skipping, right? They often, might have titles that you're unfamiliar with in terms. And, some ways you might choose what sessions to attend is ask some of your new friends here, which sessions are they going to? Ask people at coffee breaks, choose randomly, you might learn something new, or, you could do a little bit of research, read some abstracts of the talks. It's convenient. You can just click on the talk and see the abstract. Yeah, and so we have a huge conference happening now. There's going to be multiple sessions running in parallel. And so you can see one talk in one session and then be like, oh, well, there's this other session and there's a bunch more talks in there that I might be interested in. And it's totally fine to switch between sessions. Just be careful, opening the door to the hallway, people are talking, just try and do it like quickly. But it's totally fine to switch between sessions. So my advice to you is the keynotes are often very, very good. I recommend and I try to attend all the keynotes in a conference because they're done by experts. They're over a long range of research and you learn a lot from them. So an example schedule that you might have is you might attend, the morning keynote. There's a coffee break for some much needed coffee. You might attend the morning session, have lunch, maybe leave lunch a little bit early to take some, take a nap, to rest, to do some tourism because we're in Singapore and it's lots of cool things to do. Might attend instead the second afternoon session and then attend maybe a reception dinner or call it an early night, right? So rest is super important during a conference. You're going to be here for an entire week. We're all still adjusting, not necessarily all of us, but many of us are adjusting to the new time zone. And additionally, your brain is working super hard. You're socializing with new people, all that. So don't end up like this, 3 coffees, no lunch, drinking a bunch of caffeine, not affecting your exhaustion, or like my supervisor sleeping in the middle of talk. Right, so this is all in favor of avoiding burnout. A lighter daily schedule means you attend more of the days. So for me personally, I like attending all the days of the conference. I like seeing people every day. But of course, I do often skip sessions to get desserts or, in one case, seeing my friends' cats. All right, so that's a little bit about attending your time. Let's wrap up with talking about attending research talks. So I will start by saying research talks are very difficult to understand, especially when they will be at UPSLA for 12 minutes talking about a 25-page paper. It's going to be hard to understand. And so a little bit about why research talks are hard to understand. Usually, research talks and papers are about a very highly specific area, as we kind of mentioned during the panel. They're most often just a teaser for the paper. They're not going to include all the exposition that they also included in the paper. They're going to assume a lot of background knowledge that you might not have. And primarily, they're kind of aimed at experts, right? To start a conversation like, hey, this is a new thing I did. Maybe you will find it helpful. Let's start a potential collaboration, things like this. So they're not at all like a lecture. There's no explanation for things. There will be a bunch of symbols flashing very quickly. And it's totally okay for it to be sitting in a talk, having things totally go over your head, right? I kind of just think of it as not really attending and understanding, comprehending research talks. Is more like marinating, maybe. You're just like letting your brain see a bunch of terms you don't know. Maybe you're spacing out a little bit because you've kind of lost it. You're sitting in confusion, you're trying to catch up. All these things are very true. And of course, I do a very highly specific thing. When I start learning about somebody else's highly specific thing, I'm sitting there very confused. And so kind of recognizing this about yourself, that you're going to be sitting there and being confused, is really key to actually getting something out of a talk, right? So really become comfortable with sitting in the unknown. So what one could get out of a research talk is sort of, the structure of research talks, the motivation for certain research, high-level components of a solution. These are all fantastic things to get out of a talk. Most likely, you will get the fact that research talks are confusing. Lots of terms to Google later, right? Lots of funny symbols. I mean, what is this? What is this D-flap rule? This is from one of our panelists, Anton. First order laziness, which will happen tomorrow at 2:30. And it's during the distinguished papers session. So there's no other session running in parallel. You should definitely go check that out. So again, I'm going to recommend that you just relax your brain. You let yourself marinate. We're all at different stages, and we're all here to help. If you found something confusing, that's a great way to start a conversation with one of the speakers. And yes, I still struggle with this. It's really just about drowning your brain in as much information as you can. Okay, so my final advice for real is to journal every day. Lots of things are happening. You might think, I'll remember to do this later. Most likely you will not, myself included. So I try to journal every day, people I've met, things I've learned, talks I've attended, just like even briefly during the coffee breaks I've even started now. So to recap, conference is a lot of people, a lot of potential friends, potential collaborations, potential advisors. And you want to maintain your own personal schedule so that you can last the entire week here. And recognizing that research talks are really difficult to understand. You won't understand everything, but you will certainly get something from attending them. I'll just skip this. And I will say that a bunch of us from our research group are giving talks, including myself. So I encourage you all to check that out. And thank you very much. Oh, I guess I should say I can take any questions if you all have them. Yeah. Any tips on how to join conversation circles? I mean, it can be very nerve-wracking. So like one thing is if you see somebody that that's a good way. And then, introduce yourself or just have your friend introduce you, things like that. But yeah, it is very nerve-wracking, and having somebody in the group helps a lot. But otherwise, we're all here to talk and hang out with each other. So it really generally is people are very welcoming when you come and join them. It feels very scary though. I acknowledge that. Yeah.
Not your fault.
That is fair, yes. It's that time of day, eh?
With remote friends, like if I'm ignoring you, I don't hate you. I promise. It's very difficult.
Yeah, how to keep in touch with remote friends. Well, back in the day, I used to use Twitter. That is gone kaput. So now I'm on Mastodon. Oh, speaking of, actually, I forgot to put my email. Here we go. That's my email on my website. I said I would give you my contact information. Email is another way. Discord seems to be cool with all the kids. You could start a Discord, a PLMW Discord. There is the conference one, but if you want something more private, that could be a good way to do it. But yeah, social media is one way, unfortunately, that I do it. But otherwise, email is good too. Or mass. I mean, Discords, yeah, like group chats, things like this is a good way. Yeah.
Do you have any advice on what to do if you say something really intellectually embarrassing?
Oh. Advice on intellectually embarrassing. I'll tell you a story about something embarrassing that I did, which is I was talking to somebody. They were a student at a student research competition. They had a great poster. It was very relevant to my work. We're chatting it up. I say, hey, have you heard of this paper? And they were like, yeah, that's my paper. So I did not recognize their name from that paper. So my advice is, it happens to all of us. Acknowledging, you might be wrong about something, and it's totally okay to be wrong about things. I still am trying to learn this myself. That was incredibly mortifying experience. But we've become very close after that, so. Anything else? Yeah. Yeah, I went to UBC for my master's, and now I'm there for my PhD.
Okay, and
My undergrad was at Indiana University. Yeah.
I noticed that there's a lot of like abbreviation.
Mm-hmm.
Are there any in particular that you might be relevant?
There's a lot of abbreviations in the sessions. Is there anything that's more relevant to early stage people? I don't know. We can talk offline about particular abbreviations, but you can always try like looking at particular abstracts and try and see if they actually expand what that acronym is, or in the intro of the paper. Hopefully they do, because that's the good way to do it. But yeah, I don't know if I have any right off the top of my head, but we could go through the conference sessions and talk about it. Onward is good for that. Yeah. Onward is kind of this more talking about sort of great future. I think there was a question about like where the future of PL is going. Onward is a good workshop for that. Yeah. I don't know when I should stop. Just let me know. Oh, all right, last question.
When you say that a lot of folks end up flying for that, when this happens, I get the sense that I'm kind of wasting my time, and I get this sense of like, I'm lost in that. Is this the way that, like, is this a bad way to?
Yeah, so the question was, when I feel lost in a talk, it feels very frustrating that I'm not understanding, I'm perhaps wasting my time. There's a sense of urgency and I want to kind of move on. Yeah, time is a very limited resource. And I think I'm going to get a little bit philosophical here because I've read a book recently about this. And, we have this perception that, we can get control over our time at one point. And then once we get control over our time, then everything will be fine. But this is a fallacy. You will never have control over your time. There will be other things influencing that. And also, like, you don't actually know what will be beneficial for you in the future, right? Like, you might be sitting there and feeling frustrated and not understanding. But then, 5 years down the line, you'll be like, hey, I remember there was a talk about this. And then you go back, you find that paper, you read it, and you find, hey, I actually understand all of this, right? And so you never know what will be useful for you. It might feel like right now this isn't useful to me. I'm not understanding anything. But like even just knowing tangentially like this sort of web of knowledge is very useful. And it feels frustrating in the moment, but understanding that, this eventually might be beneficial to me is a really helpful skill. What was the book I read? The book I read is Time Management for Mortals by Oliver Burkeman. I really recommend that book. It's very good. Okay, I'll hand it off to Lucas.
Hopefully, if I can now share my screen. Use. No, you're good. You're good. No worries. Okay. Thanks, Paulette.